we will see some basics, right? So we will next 5-10 minutes. I'm going to spend a little bit on why you need to learn SQL to understand the SQL environment. What is SQL? What is it all about? How people normally use SQL? What are the different types of SQL servers available? That we will first cover. So why do you need to learn SQL? Typically, right, SQL, you can say it as SQL, or you can say it as, people sometimes say it as SQL also. It is used to communicate with databases. Now, like this is a digital age, lot of data is getting collected on a daily basis. Still, a lot of data is structured data. 90% of the data that companies collect are still structured data stored in some sort of a database. A lot of the data is a relational database. All right. Now, SQL is the language. SQL is the language that's the most popular, widely penetrated, very, very common in any company you go. People will typically are going to be using SQL. Even in companies that are using NoSQL typically, like there are databases that does not use SQL also. They do exist, but that is a small component. Most jobs, most database systems, people normally use SQL, right? In order to communicate with databases, to retrieve and manipulate data, people normally use SQL. All right. So now, if you are into data science, you are going to be working with data, right? Before you start building your machine learning models, deep learning models, whatever modeling that you are going to be doing, you need to retrieve and wrangle the data from various sources. These sources are typically databases. Right? If you are going to be refreshing or maintaining your models on a regular basis, right? You are building your model using a CSV file. That's fine. But when you're productionizing your model, you're going to be pulling the data from various different sources first, right? You'll pull the data from various different databases, put them all together, form your data set, and then build your model, right? This process where you are pulling your data from multiple different sources and assembling it and creating it in a nice tabular format for you to reproduce it on a monthly basis or whatever the refresh rate frequency is, right? So before data modeling begins, SQL is there. You need to take care of putting your data together, then that's where SQL helps. So in certain companies, this job, like there will be data engineers who do this activity and make the data available to you for you to directly use it. But typically, in most cases, data scientists are expected to pull this data from various different sources, put it together yourself, and then start building your models. Right? If the help is not available, the data scientists themselves have to do all these things. For that, SQL is necessary. All right, that's the reason why we need to learn SQL. Right? There are more advantages of why we need to learn. We will come to that separately. Now, a little bit of history. SQL was first developed. Let me try to make this a bit larger. Okay. SQL was first. See a couple of chat. Okay, great. Okay, it was first developed by IBM. It's been like more than 50 years now. In 1970s, was first developed by IBM by Donald D. Chamberlain. Most people don't know these folks' names. Donald and Raymond. So they originally developed it in IBM. It later became the standard, and all companies started adopting it. So it was standardized by the American National Standards Institute, ANSI, if you have heard this name, and the international. It's very, very difficult. All the legacy systems, all the databases throughout the globe use SQL. There's no plan that we are going to supplant SQL with some other programming language or things like that. People say, okay, yesterday there was R programming and then Python came and took over R. This kind of talks can happen with Python programming languages. But with respect to data wrangling, there is no competitor for SQL. All right. So SQL, if you learn SQL, you have it for life. All right. Now, why learn SQL? As I spoke, SQL and relational databases are everywhere. We're not going to be talking about what relational databases are. It's not required on a practical purposes. Just remember, relational database is a type of database where you pull data from. There are multiple different types of relational databases. You just pull the data from those databases and you're going to start working on. We're not going to go into the theory of what a relational database and all these things. This is not necessary for us right now. Now, it's as simple as that. Now, it's helpful in like how I explained, it's helpful in pursuing a data science career. It's a necessity. As a data scientist, if you want to do anything with data science or data related careers, having a knowledge of SQL really help. even for product managers, even for product management and data analysts who work in some way with SQL, right? Like when you're working as a product manager in data science and related streams, you still have to create your dashboards quickly, pull in data from some various different sources, create your own dashboard and present it to someone. To do that independently on your own, if you know SQL, you can do a better job at it, right? So that's very much relevant for such non-technical roles also to a certain extent. Now, almost every data technology today supports SQL in some form. You can handle large amount of structured data. Very easy to learn. Learning SQL is no big deal, right? But how do you get various things done in SQL? How do you understand how SQL works behind the scenes? That will give you the confidence to tackle any type of data, any type of data problems, any type of data wrangling that you want to do. If you gain that confidence, then you are good, right? That's what we are trying to achieve in the next 3 classes. Okay, so data management is an in-demand data skill. It's used for data analysis, interoperability, right? Like I said, every other data-related technology has some way of working with SQL. So if you're running Python code, it is possible to write SQL or interoperate with SQL, integrate SQL into your Python code and do your various data science queries, data queries. So that is there. Integrations with various other languages. This is Python and Java and all those is present. Handling large databases, long-term relevance. That's nothing going to replace SQL in near foresight, right? Nothing to worry about of like having to learn a new technology to do all these things. Ease of learning, very easy to learn. Let's now understand the types of SQL servers. We are going to get into the hands-on in about 5 to 7 minutes time. Before that, we are going to let's understand the different types of the SQL servers so that you are understanding what are the different options available in the ecosystem. Now, the most common type of servers are the Microsoft SQL Server, right? MySQL is also very common. I would say this is very popular. And we are going to be implementing or installing this today in today's class, today's session. Microsoft SQL Server also very popular. Both of them are very popular. In fact, all of them are actually popular in some form or the other. But the SQL language, the core of the SQL language is the same across all these different servers. That does not change. Small syntactical changes might exist, but you can quickly adapt to it instantly, almost instantly, maybe in 10 minutes. Small syntax changes will be there. You can quickly make those adjustments, and you'll be able to use SQL across all these databases and servers. PostgreSQL. So this link, right? Though each of this is a link, it will take you to the download page of each of these different servers. Okay. Now PostgreSQL, Oracle Database, MariaDB, IBM DB2, Amazon RDS, Google Cloud, Azure SQL Database. So within this, these are all cloud-based databases, right? You can you can run it on the cloud. Various different remote computers you can run this. Within Amazon RDS, there are multiple different SQL databases within this, right? So that's the way. These are quite larger areas for you to learn. So if you go into Amazon RDS, right? Within that, so this takes you to this page. And if you look inside this, they have multiple different options, say Amazon Neptune, RDS, DynamoDB, Redshift, various different options exist. All of them again use SQL. All right, they are used for their various different purposes. No need to worry about those aspects now. Today we are going to be focusing on SQL. Now, and Apache Hive, right? Hive is another query language like SQL. There's something called HQL, Hive query language. This is also very much almost the same as SQL. Whatever you are going to be learning today, all those commands exist in Hive query language also. Now, let's understand a little bit of the concept. What is a database and a table? Very simple. Understand it this way. Think of a library, right? All these libraries contains lots of racks and rows, right? So this entire rack, you can think of it as a table. This entire rack, you can think of it as a table. And this rack is made up of rows and columns. This rack is made up of rows and columns. So this is how a table is structured typically, right? And a database is the library itself. It's a collection of all these different racks, the table, all these different. So each of these are tables here, right? Each of these racks here, you can consider them as tables. And and here, suppose this is like comic books. This could be comics. This could be, say, novels, something like that. Each of them have books that are similar to each other arranged inside this rack. So if these are all comics, the data that is related to each other are going to be present in this rack, isn't it? So this is how you can think of a database and a table, as simple as that. A database is basically a collection of tables. All right. And this is how it is typical. This particular symbol, wherever you people write this particular symbol in schemas and all, right? This represents a database. Sometimes people also draw it like this. Draw it like this, something like this. This is a universal symbol for database, representing databases, just for understanding. So inside the database, you have multiple tables, and each row in the table is called a record. Right? Each row in the table is called a record. A typical SQL syntax is like this. We will get into the details of this. Typically, whenever you are writing a SQL statement, you will have a select command, you'll have a from, you'll have a where, you'll have a group by, having, count, order by, all these things. A typical command, right now we will not get into what these are. It's quite easy to understand. By looking at it, you probably can understand what this is talking about. But generally, this is how a typical SQL commands looks like. Okay, now let us set up the Python environment. What setup? The setup that I am currently having here, right? This is the setup for running Python. Here, I can start a new cell. This is called the Jupyter notebook. Okay, I'm selecting this cell. I just clicked on it. This got selected. I click A. I press A button. A new cell gets opened here, and I can inside this cell I can write Python code. Inside the same cell, we are going to be writing SQL code in today's class. I'm going to show you how to do that today. But in order to do that, you first need to have this setup, right? How to do this setup? What you need to do is just do a Google search for Anaconda. Just going to click my dashboard. I think I'm going to do anaconda.org. Go here, and there should be some download option. They keep changing this first page. For some reason, they always keep changing this. This is usually not what I get. Okay, you have the download Anaconda. By the time that you are going to be reviewing this page might again change. Whatever the format of this page is, locate download Anaconda. It will take you to the download page. Right? And right now I'm on Windows computer, so a Windows download is already going to be available. Just click on this. It will download the Anaconda distribution. Just like installing any other software, go ahead and install Anaconda. Once you have installed it, if you are using Windows, go to your start and type Anaconda. If you type Anaconda, just like command prompt, you will get an Anaconda prompt. Type Anaconda. Here, you get the Anaconda prompt, right? You need to click this. This is different, slightly different from CMD. If you type CMD, you will get command prompt here. Not this one. We are not going to use this one. You need to type Anaconda. You will get this. This will open a new screen. This will open a new screen, something like this. Here, you need to type Jupyter Lab. If you issue this command, this window will open. A brand new window without any of this, right? I think I can show. The launch screen is not here. This window, basically this particular window will open, right? Here you can start a new notebook. You can click the plus icon and it will start a new notebook. You can click here and it will start a completely new notebook, and you can start writing your code here, right? Now, if you need to know more about this, if you need to know the exact full steps and process of how to do all of these things, how to do the complete setup, for Python, I strongly recommend you to enroll into, this is a free course, enroll into this Python programming course. This is present inside Machine Learning Plus, okay? So these are two videos. You can refer to these two videos that is present inside this course. I'm going to show you. Let me paste this. While I am doing this, please pull out your computers, open your computers, click on this link. That will take you. I'm going to show you how to do that. Let me open an incognito tab. Control V, and that will take you to this particular page. Visual Studio Code is also fine, perfectly fine, Pavan. If you are comfortable with Visual Studio, please go ahead with it. If you're not comfortable, just follow what I am saying, right? You can do the same things. If you are already comfortable, use Visual Studio. Visual Studio is not a big deal. Now, once you are here, this is a free course. You can see the complete Python programming here, right? Now, click Enroll now. It will ask you to sign up. Click Sign Up. I think this is the same process of what you did to join this class. Enter your name. If you are already signed up, you can just log in and then you can enroll now into this course. Now, what I'm going to do, instead of signing up, I'm going to log in. I'm going to log in to Selva, not Selva. I'll use a different account. Response at gmail.com. All right. Give in your password, whatever you have set, and log in. All right. Now you are logged in now. Once you have logged in, if you have not already enrolled, this button will be Enroll Now button. Okay, click Enroll and you will be taken inside the course. I can click Continue. Alternately, I can go to My Courses. I've already enrolled in here. Inside this, you will be able to see the Python programming appearing here. All right. Now, if this is all confusing, what you can simply do is you can go to machinelearningplus.com. Right. Once you have enrolled, you can go to machinelearningplus.com. Under Learning Paths, once this loads, you will have learning paths. Click here. Just taking you to my internet is super bad today. Okay. If you click on the data science career path, right? This is the course that you can sign up for. So this is the course where you can, this is a free course. You can, if you click here, it will take you to the Python course. So once you are inside this course, once you are inside this course, the videos that you are looking for are these two. Under installation videos section, you have two videos: Python setup local installation. This video that I'm showing here, this will play the exact steps of what you need to do to install Anaconda and how to work with Jupyter notebooks. Everything that you need for local setup is present in this video. All right. Alternately, you can, if you are not comfortable, if you think there's a lot of thing, if you are already comfortable with Google Colab, you can run all the code in Google Colab also. How to access and work with Google Colab is present in this particular video. All right. This video will tell you how to work with Google Colab. Google Colab link is colab.research.google.com. If you go here, this is the space. This is the place where you can access Google Colab. Just like Jupyter notebooks, you have collaboratory notebooks. This is a Google Colab notebook. I prefer the Jupyter Lab interface that we are currently using, more comfortable. I like the interface. It's slightly tailored for our needs. I'll be continuing with that interface. We are going to set up some more additional libraries we will need to set up in order to work with Jupyter Lab. Now, I'm going to assume that you have your Jupyter Lab open, right? You need to start. What you need to do is if you have Jupyter notebook installed, you need to start Anaconda prompt. Open your Windows, type Anaconda prompt. This window will open. I'm saying this one more time. This window will open. Here, type Jupyter space lab. You can do this, or you can use Jupyter notebook also. Jupyter space notebook. All right. I am using right now, this screen I'm using is Jupyter Lab. You will get something very similar to what I'm currently using. Okay, I'm going to close this. So this screen you should already have. All right. Now, this particular example is just for demonstration purpose. You don't need to run this part for our demonstration in today's class. This is just an example. Okay, so I'm importing. So I have already, if you haven't installed Panda, if you're installing Anaconda, Pandas will be installed by default. If not, if you're facing any trouble, do pip install Panda. So how you do it is select this, open a new cell and write pip install pandas, and that will install pandas library. All right. Once this is done, I'm going to delete this. DD will delete it. Okay. Once we are going to be reading this particular data set, data SQL.csv. This is present inside the project folder. So inside resources folder, you will be able to find most of these files. Inside this, you should have data SQL, data SQL.csv. So this is the file that we are going to be importing now. Okay, this is a problem. It keeps scrolling. Okay. Right. So we have imported this. The contents of this file, this file contains a lot of different rows. Only the first 5 rows is printed here. Current ID, dependent variable, logic variable, 5 different variables, just random data. This is all random data. Now this made up data, not random, made up data. Now what we are going to do is we are going to do all these different steps. We are going to be creating a database, creating tables, loading tables, selecting the data, basically working with the data, right? All these different steps we are going to be doing shortly. Now, first step to be working with SQL, you need to create and run SQL in the Jupyter environment. First, we are going to be setting up the Jupyter environment. Then the next one, we are going to look at how to set up the MySQL environment or MySQL Workbench. Both of them we are going to see. So first, I'm going to assume that you have already installed Anaconda and you are having access to Jupyter Notebook. Now you need to first install this particular library, just like how I showed how to install pandas, right? Run this particular command in a new line, new cell, and that will install SQLite 3. Right? SQLite is a very convenient database in order to work with SQL, work with a SQL database from inside Python. You have an equivalent procedure to do MySQL or most of the other databases. You can connect to it. For this, our example, we are going to be using SQLite 3. Now, what I'm going to do, I'm going to restart the entire kernel. Let me restart it. In fact, let me clear all the cells. Clear all the cells outputs, restart it, done. Okay. Now I'm also going to go here and delete this particular database. Okay. Before this, I had run these commands that will create this database. I'm going to delete it. I have deleted it now. I'm coming back here. All right. Now, assuming first step is to install this, to install SQLite db-SQLite 3. Once you have run this command, you will be able to import SQLite 3. Once you have imported this, we are going to connect to a database called Jupyter SQL_tutorial.db. If this database already exists, it will connect to it. If this one does not exist, it will create a new empty database. All right. Now we just deleted this, so it does not exist right now. So I'm going to run this command. So it has run. So there is this created database is saved as test_db. Okay. Now using SQLite, we are going to this is another. If a database does not exist, running this command will create a new database. Okay, running this will create a new database if it does not exist. We are calling it as test_db. We will not be really using this, so ignore that. Now, one more thing, before you run the next command, next one is we are going to be loading the SQL magic command, SQL magic command. So to load it, in order to run SQL from within Jupyter, you need this. To make that happen, you need to first install IPython. Where's my pen? So you need to install IPython-SQL. You need to first install this using pip install IPython_-SQL. Once you have installed it, right? Then once you have installed it, you can load up SQL using load_%load_ext, then SQL. Then I'm loading up this particular database that we just created, %SQL SQLite : /Jupyter SQL tutorial. All right, this is a one-step process. Just one time we will need to run this in order for us to use SQL or run SQL from inside Jupyter Notebook. I'm running this. Okay, so this has already done. We are now in a position to run SQL. All right. Now, in order for, in general, if you open a new cell, right, whatever code you write, Python, Jupyter Notebook will understand this is Python. pd.read_csv. This will run whatever. So if you do a print something, it is going to run it as a Python code. Jupyter by default understands this is a Python code. Now, in order to tell Jupyter that the code inside the cell is not a Python code, but it is a SQL code, you need to add this particular magic command, percentage SQL. So all the cells that we are going to be running henceforth will have this. If you are running a SQL command, it will have this. All right. Otherwise, it will be understood as a Python code. That's the difference. So right now in this notebook, we are running both of the languages, both Python as well as SQL. We are going to be running in this entire notebook. All right. So now we have loaded up. We have let SQLite know that this database exists. It's an empty database right now. We have let SQLite know that this database exists. Now we need to attach this database to a particular name. That's what we are doing here. So let me run this. Attach database, attach this particular data, the same database that we had just created, and save it as test_db. All right. Let me see if there are any specific questions. From where can I get these files? Girijesh, this will be present inside the resources folder once the live class. So after the recording is done and the course is available on the platform, it will be available as a resources folder inside that file. The particular CSV file, no need to run that particular code now. All the tables that we are going to be creating, we are going to be creating those tables from inside this notebook itself. So don't need to worry about having to need a specific file. Can we use MySQL Workbench? Yes, absolutely we can use. I'm going to show how to install that next. Okay, can you share the notebook in chat? The notebook, please hold on to that, Leela. Whatever we are typing, right? The code that we will be executing, the code that it's hard to type out, I'm going to share it out from inside the meeting chat itself so that you can try it out. All right, so let me first start by sharing this out. Sharing this particular piece. All right. Then you need to connect it. Right. Then you need to copy this, pasting it here. Okay. So the connection is done, and then finally attach the notebook. These are the four different steps you need to do in order to let SQL know that this database exists. All right. So now you have attached the notebook. Right now, SQLite knows that there exists a database called test_db. Okay. Now, once this is done, I am going to this particular database. Right, we are not. This is just a command. No need to run this particular part. We are going to recreate everything. We are going to recreate. Let me just for the sake of knowledge, right? Let me share this code also. At this point, I get an error. No module name SQL. So you need to, if you get that error, right? You should install. You need to do a pip install of this particular library. All right, pip install db SQLite 3. All right, so once that's done, that error should go off. Great. Okay. Now, no need to run this command. Till here, no need to run any of this. No need to run. Just practice till this part. Just till this part. We are not going to be using this particular data frame. Now, sample df, this data frame that we have already loaded up in pandas. We have created this. We have imported this as a CSV file. Load it into the test_db database as sample df. So what this means is SQLite will understand this data frame, this pandas data frame is available as a table called sample df inside this db called test_db. So inside test_db, this data frame is going to be available as a sample df. This table is available right now. It's been moved to the database itself. right? That process is completed. So we now have a database called testdb, and inside the database we have a data set called table called, it's not a data set, we call it as a table. We have a table called sample df. Now once this is done, we can write our SQL. So every command here, right? Every command here, see this command, select star from database dot table name, right? This is a general SQL command. We will revisit this again. And in order to make this work in SQL, you need to always have this, remember. All right. Limit 50, we will come to this. So this ideally, let me remove this part. If you remove this and run this, the entire table will be printed out here in this command. Okay, no such table. Probably I have not run this step. Okay, now if I run this, again, no such table. Sample df, maybe I did not run the first code where we imported pandas. I need to read this one. All right. So once this is read, once this is done, right, this should have errored out. That this one since I am using it inside a try statement, this is not showing the error. Now it has run. Let's try it out. Now select star from this. It should print out the entire table now. Let's wait for it. Okay, the entire table is getting printed. Now this is very long, right? This table is very, very long. The entire thing is getting printed out here. So instead of doing this, what I'm going to do is we are going to just print out the first 5 rows. So again, see here the syntax. No need to by heart this. Just observe the syntax. So select star from the table name, database name dot table, followed by limit. Limit is equal to limit 5 means it will just print out the first 5 rows, the first 5 entries or observations. It will show out in the console. All right. So we get only the first 5 rows. Now here this is going to occupy a lot of space. So instead of having the entire thing, I'm going to limit this. This is what we had done earlier. Limit this to only 50 rows. All right. So it does not take a long space. Okay, all done. Now here we have just the 5 entries. How to count the entries? Again, no need to by heart now. Just showing you a demo of what comes later on, right? Count star will count the total number of observations from this particular table. All right. So totally 14,989 observations exist. All right. This is the number of rows that exist in this table. This is how you count. Once you load up the table, right? Immediately you will want to know how many rows and columns exist. That's how typically Python programmers think. Now, this way we found out the number of observations that exist in the table. We have a sense of it. Now, if you are a Python programmer, intuitively you will also want to know how many columns exist, right? But that is not the way how you think about Python. Think about SQL. That's not the way how you think about SQL. We will come back to that concept. Now, in order to, if we will see the difference between SQL and Python programming shortly in the next one. Before that, we normally do not worry about the number of columns that exist. Why? I will tell you shortly. Okay. If you really want to know how this is done, how to compute the number of columns that exist in the data, right? The way to compute the number of columns can change from database to database. Right now, we are using SQLite, right? Inside SQLite, this is a command. You don't have to by heart this. This is a command. So inside pragma table info, this particular command, pass in the table name, right? Inside this will tell you. So pragma table info will tell you the names of the columns that exist in this particular table. In this particular table called sample df. Right? By using this command, we are able to get the number of columns. 9 columns exist here. In this output, there are 9 columns here. That's how it is printing this particular output. No need to worry. Don't by heart this. Likewise, in MySQL. So how to do the same thing in MySQL? You click on this link. It will show you. So if you run this particular command, don't worry about this now. I've just given you the resource of how to find it out. Don't implement it now. Okay, don't implement it now. You need to run that particular command in order to get it. This you will appreciate it better shortly. Once we get through the course, you will appreciate these commands better shortly. Right now, this is how we find out the number of columns. It can change from data server, database to database. How to think about data wrangling with SQL versus Python? Like how to think about, let me see the specific questions. No need to worry about sample DF right now, Priyanka. We will not be using, that's not the flow of this. I'm just showing a demo of what sample DF is. Sample DF is a pandas data frame that's available in the course resources. We'll be sending out shortly to the students when this course becomes up and live, right? So it's a CSV file. We loaded the CSV file into the database and we completed and loaded the CSV file as a table inside the database. That's what we just did. We'll quickly review it again shortly. Yeah, we'll do a quick review of that. Anything I missed? Okay, Neetu, you are getting module SQL error, right? You need to do pip install db-SQLite3. Without that, the SQL command will not run. Yeah. Okay. So yeah, I understand. I went too fast. I read ahead of time. We are going to slow back again and come from scratch again. We went a slightly bit ahead of ourselves with respect to speed. We will take 3 steps back right now, and next step we are going to be installing shortly. We are going to be installing the MySQL Workbench. That is a process in itself. Like today's class is actually light. Okay, we need to just understand. Don't worry too much about the syntax. We have a lot of time to cover the syntax a lot more in detail. Focus on the concepts. Understand the SQL environment right now. Okay. Now let's understand what's the difference. What's the difference in data wrangling between? Let me close out this window. Also, these are not needed. All right. So this is especially useful for folks who come from Python background. If you know NumPy and Pandas and know how to do data wrangling in Python, then you will be able to appreciate this better. But nevertheless, the fundamental difference between SQL and Python programming, right? Now, both of them in SQL, always you have a database. You have a database. Inside the database, you have a lot of tables, different tables stored together, and these tables may be related to each other also, right? All these relations might be this might have a column common between them. So these kind of relations might exist. So all the tables exist in a database in SQL. All right. Whereas in Python, typically you will have a CSV file. This file you will load up using pandas. You will load it up into Python. Right. Once you load it up, it is available as a Python object. This CSV file is going to be available as a pandas data frame if you are going to be using pandas. Right? If you're going to be using, say, NumPy, it's going to be available as a NumPy array. Right? Likewise, many other data wrangling libraries exist. Like recently, Polars is more popular. Polars library is getting more popular these days. There is modern various different libraries exist, but amongst all, Pandas is the most common one people normally use. Whatever it is going to be available as a Python object. There is no standard one single format to represent data inside Python. It's all data structures. The Pandas data frame is another data structure, just like how you have lists and dictionaries in Python. You have a Pandas data frame as another data structure. Right? It depends on how the author of that particular package has defined it. Right? In Pandas, you have a data frame. In NumPy, you have it as an array. Right? This process can change from package to package in Python. But in SQL, it is just one common single framework for everybody using SQL. That does not change. You have a database. Inside the database, you have a table. You have various different tables. All right. Now, that is one thing. Second thing is, let's assume we are going to be working with a table, right? In SQL, it's going to be called a table. In Pandas, is going to be called a data frame, or in Python, let's call it as a data set. All right, in Python, I'm going to call it as a data set. This also has rows and columns. Tables also has rows and columns. Tables also has rows and columns. Typically, in SQL, right, you have only rows. You have only rows and columns. Whereas in Python, say for example NumPy, this can be three-dimensional. Right? It can be three-dimensional. It can be multi-dimensional also, more than 3 dimensions also, which we cannot visualize. Right? That way. Now, even it can be that, like it can be multi-dimensional in Python. But let's assume we are going to be dealing with only tabular data. Let me erase all this. We're going to be dealing only with typically structured data is going to be tabular data with rows and columns. All right. Typically, structured data is going to be tabular data. I hope we can agree on that. Now, here you have columns and rows. This is Python. This is Python, and this is SQL. All right. Now, in SQL, another difference between SQL and Python is in Python, you can define your own function. You can define a function to say replace missing values. Replace missing values. You can define your own function. You can define your function to say handle outliers. Right? You can define your function to say filter out specific part of the data. If say you want to filter out this cell, this cell, this cell, you can define your own function, or you can simply write a for loop and then extract these specifics, quantities, or specific data points in this data, and then store them as a separate list. You can do this in Python. I'm not saying you cannot do this in SQL, but typically this kind of operations you do it in Python, right? How would you do it? Say you want to extract these cells. Maybe you will iterate from this particular, say this is row, this is column number 3, this is column number 4, 5, 6, column number 6, right? You will iterate from column number 3 to 6. If row number equal to 2 and this is 5, right? 2 and 5, extract this value. If row number equal to 3 and column number equal to 3, this is 3, 3, this is 2, 5. Right? You will extract those cells, those values, and store it in a list. You can do that in Python. SQL, we don't do that. I'll tell you the difference. In Python, right, you can refer to the columns as 1, 2, or rather in Python, you will refer to it as, let me use a different color. You'll refer to it as zeros, 1, 2, 3, 4, 5, and so on, right? Whereas in SQL, we don't do that. We don't have a column name called 1, 2, 3, 4. We don't do a column indexing. We refer to the columns only using the column names in SQL. Right? We only use column names. That's a major difference. Now, the thing is, in Python, you can define your own function. You can customize your own for loop. It's a very, very common activity. People do that all the time. Whereas in SQL, we have a definite. It is possible to define your own function, but people normally don't do that. But typically, what people use is definite. You can define your definite. No, you cannot define. There is a definite set of commands. There is a definite set of commands, a specific set of commands in SQL, such as the select statement, select. You have, let me use a different color. Select where. WHERE, where, join, these kind of statements exist, right? We typically use these statements to do all the different data wrangling operations. We use the pre-existing set of SQL commands. And any command that you do, right? Say you want to do certain operation on an entire table, you look at the entire table as one single unit. You don't look at, okay, I want to get this cell, I want to get this cell, this cell, this cell, like that. We don't think like that. Suppose if you want to filter out this data, right? If you want to filter out these particular cells, forget this. We typically won't do this. Or just do this kind of an operation. Say if you want to extract this kind of rows, what you would do from the entire data set, select this column first, take this entire column, right? Take this entire column, and there might be some criterion based on the number of the values of this, or some kind of a criterion. Based on that criterion, you can select those specific rows out of this particular data set. That's typically how SQL commands are written, SQL queries are written, right? Hope you can appreciate the difference between how people write data wrangling code between SQL versus Python, right? If it is clear of how the difference between writing data wrangling in SQL versus Python, please write yes on chat so that I know you're following along. Especially if you're coming from a Python background and have been writing Python code or even R code all your life and you want to learn SQL, this will be very useful. Set up the MySQL workbench. The workbench typically is going to look like this. This is my current MySQL workbench. This is how it looks, right? What I'm going to do, if you have a computer, please follow along with what I'm going to be doing, right? What I'm going to do, I'm going to first uninstall this. How I'm going to uninstall is the same file that I used to install MySQL workbench. I'm going to open it up. Right? This is the MySQL installer. Now, how to get this? I will show you how to get this. We'll go to this. We'll see the exact links on how to download the installer and all. Okay, actually, let me show it right now so that you can start your downloads. So, if you are going to be using MySQL on Windows, you need to go to this particular link. Okay, this is a tutorial. Okay, here are the steps. Go to this particular link. Let me paste this in chat. Go here. Right here, select the version, Microsoft Windows. This is all fine. Whatever it shows as default, pick that one, and click on download. Click the bigger one. It will download the entire installer. Click on download. Let the download start. Meanwhile, I'm going to come back here. Here, I'm going to select MySQL server. I'm going to select the MySQL server and click remove. Then it asks me what all products to remove, right? I selected everything and I'm going to completely remove everything, right? Next, execute. That will uninstall my entire MySQL workbench. Let it happen while you are downloading your MySQL installer. Okay, I have entered the link in the chat. Please go to that link, download it. If you're facing any problem reaching that link and unable to download, please write it to chat. We can resolve it while my uninstall process completes. This can take maybe 20 seconds or so. Please hold on. I'm installing, just a sec. Maybe 10 seconds, I would expect. Wait a minute. So this, while installing it, installing this one, right? Okay, you want a Mac link. Thanks for asking that. I don't have the exact link here, but if you want to find out, I can find it out for you. Okay, wait. So here you have the operating system here, right? Select this. It does not have a Mac. Okay, MySQL for Mac. Download Mac. Okay, so go here, installing MySQL on Mac OS. Available in different forms. Using native package, you can use the package installer. See chapter 2, installing Mac here. Then download the image, the community version. Double click. Okay, double click the file mount. Download the image. Where do I download it from? Okay. Let me give you this instructions, this link. Please follow this link. Myself, I'm trying to see where this download link is. SQL downloads. Should be available somewhere. This is heat wave, not this one. Okay, thanks for sharing that. So here I am not getting. Okay, here you have. Great. So you have to select the Mac OS here and then download the corresponding one. Thanks for sharing that, Sharmila. Great. Okay, so I hope my download. Okay, this is complete. Yes, just let us be there. Uninstall. Finish. All right. So it is completely removed from my system. Now I'm going to reinstall it. I'm going to reinstall this. So go to download, MySQL installer community. Right. Double click it, and the installation starts. So unfortunately, I don't have a Mac OS right now. I'm using on a Windows. It should not be a difficult error to debug it. Please, if you try to search for hardware incompatible virtualization error, if someone is facing this error, please help Soumya out. Not sure what the error is, but let's not digress too much. We'll stick to Windows for this particular today's session. So if you get the screen right, please follow along if you have already downloaded. I hope you have already downloaded the MySQL installer. So once this is installed, choose the full installation. We're going to install everything. Select full, click next. Right? Then again next. Keep the default wherever you are in doubt. Don't change anything. Just keep the default as it is, and then do execute. Let it install. Let it complete the complete install for this. This may again take a minute's time. Server only also should not be a problem in my understanding, Fermin. If you have chosen server only, no, it's fine. Just continue with it. If you are not getting any of the screens that I'm going to be showing in the corresponding steps, you can uninstall it and restart the installation again. But for today's class, I think you should be fine. Server only should be fine. Okay, I'm showing the entire steps anyway, just in case anyone faces any trouble installing this. So it's installing the MySQL shell. Then it should install the router, then the documentation, samples and examples. A bit of confusion can arise when you're installing this. That's why I'm showing the entire process live. The class recordings will be broken down into smaller sub lessons, and will be made available to all students. You'll have access for 1 week until the next week's class happens. Right. Post that, the access will be available to students of the Machine Learning Plus complete university package of Machine Learning Plus. We sure need to review the installation steps. So yeah, that's exactly it. So that's why I'm showing the entire steps. Let's complete this. Just give it. I think this process alone might take solid 2 minutes. Just bear with me. See all the steps on the screens. Try to follow along with what we are doing here, so that you are able to comfortable running SQL code in your own machine. Slightly slower than it usually is, but nevertheless, okay, it's done. Router installation, then MySQL documentation done, samples and examples done. Okay, all good. Next, and then click next again. Here, set the config type as development computer. That is the default setting. Leave it as it is. No need to change anything. If you want to change the port, I wouldn't recommend. Just keep the port also as it is. All right. Just do next as it is. Next now. Then you have use strong password encryption recommended. Keep it as it is. No need to change anything. Now here, give a root password. Remember this password. I usually give a simple password. This is something that I will keep on repeatedly typing. So I keep a simple password. It is going to tell me that this is a weak password. I don't care. This is a local system. No one is going to come into my computer and run all these things. So this is fine. All right. So though this is weak, it should be fine. I've given my password. Then click next. Then keep everything as it is. Don't change anything. Click next. Yes, grant full access as it is. Nothing changing. Next. Then execute. Right. It will do the necessary application processes. Let it complete. Initializing database might take a long time, it says, but it's complete now. Starting the server, applying security settings. All good. All good. Finish. Then again, next. Here, this is all like not set up, right? So if this one is checked initially, this box will be checked, right? If it is checked, uncheck it. When you uncheck it, the finish button will become active, and then you can click finish. All right. The next again. Here you can test your connection. Whatever password you earlier chose, type that password. Test the connection. Okay, the connection got succeeded. You should get this. If this green occurred, then your setup is fine. Then click next. Then checking if there are okay, this is fine. Then execute. Hope everything is fine. All right, now finish. And next again and finish. On clicking finish, it by default starts a MySQL shell. All right, this shell will come and it will also open a workbench. The workbench also will start by default. Right. Once you see the screen, click on local instance, click on this and click Selva. I mean, Selva is the password I wrote here, so I'm writing Selva here. And okay. And okay, this is a query that already exists. I had written this query earlier on. You will not see this query. You will not see any of this, but you will see these databases on the left-hand side. Probably you will start with this administration tab. I hope you are able to see that this is in small font. I'm not able to increase the font size for some reason, but I hope you can see this in this area I'm highlighting. You see administration. Ignore that. Click on schemas. This is where all your databases and tables are located. So there are three databases: Sakila, Sys, and World. Three different databases, and inside Sakila you can see these things: tables, views, stored procedures, and functions. If you expand the tables, it will show the tables that is present inside Sakila database. This is a database we will use for the exercises that we are going to be seeing in today's class. All right. So this will be there by default. If it is not there, right? If Sakila database is not there for some reason, maybe you did not install this database maybe if you chose a server only installation, that it might have missed out. It's possible. I don't know. I'm not sure. So if it is not there, just in case, in the notebook I have given all the steps involved also. Okay. So this notebook will be accessible for the students of the complete university access, by the way. All right. So these are all the different steps. You won't lose anything here. So once you get it, you will get this screen, right? Then that's it. You can start. Now, if you don't have the Sakila database, there are two things you can do. You can refer to these links and install it yourself, or what you can do is inside your resources, there will be a folder called Sakila DB. Double click this. You will see three files. We only need two files: Sakila-schema.sql and Sakila-data.sql. we will need to run these two files. First run schema and then data. All right. I don't have to run this because this is already present here. If you want to run this, right, what you need to, okay, this is the SQL, MySQL shell. I'm going to close this window so it doesn't confuse me anymore. I'm going to open this. What you need to do is go to that particular, open that particular query, right? So file, can go to open SQL script, open this. So here, in this particular folder, Sakila DB, open this one, Sakila schema, right? Select all, Control A, and run this one. Run this command. Right? This particular cell, click on this, it will run the entire code here. All right. It deleted that particular Sakila, right? Sakila database. It had deleted it, and it would have recreated it also. If you type the refresh button, Sakila has come back. But the tables does not have any data inside it. The tables are created, but it does not have any data yet. To get the data, I'm going to run the next query, which is open SQL script, Sakila.data. This is the guy, right? Control A, select all, select everything, and run this entire thing. All right, I think it is completing the run in the bottom. The status is appearing in the bottom here, right? You can see. So it has run everything, I think. So it has run the entire query. The data is present inside this query. All right. Now all these tables have been populated. That's it. That's how you create the database to run your commands. All right, two different files. No need to do it right now. This step, no need to do it right now. I'm just showing you how to do this just in case for a future exercises. All right. Now let me do a quick check. Any of you facing any trouble installing the MySQL Workbench? Any trouble? Is everything that we have discussed so far clear? First step is to create a table manually. The most commonly used command in SQL is a select statement to retrieve data from various existing tables. But we will also need to know how to create a table. People who are not having properly learned SQL and try to just randomly run some SQL commands, right? They will typically run the select statements. But to create a table on your own, you need to define the schema. One thing is one way to create a table is you can define the schema from scratch for that particular table, and then from that we can select the data. So here we are creating the schema, creating the table itself. First step is to create the schema for this table. So create table. So this is the exact syntax for doing that. Create table. Create followed by table. Write the table name, and open the brackets here. Open the brackets and close this. Right now, inside this, define the column names, variable type, right, int, and wherever it is a primary key. Primary key means so in every row in the data, right? So this you have the data set, you have the table here. Now, so it could be very much possible that certain rows here, say you have customers data, right? This is customer 1, customer 2, customer 3. Again, customer 1's data can exist here. So this is the age, salary, some kind of data, demographic detail data is available. Let's say customer ID. All right. All this information present here. Suppose if this entry and this entry is exactly the same, it would be a duplicated data. Right? Typically, datasets will not contain the SQL datasets will not contain this kind of duplicated data. The row or a combination of rows that can be used to uniquely identify a certain record in the data. Right? Say here, this particular value occurs 2 times. Like this is customer ID 1, this is also customer ID 1. Right? But primary key is 1, where typically the ID will not repeat. If this is supposed to be a customer table, this will be ID 4, ID 5, ID 6, so on and so forth. All the different customer IDs will be present here. If you can, the column based on which you can uniquely identify the entire observation in the data set is the primary key. right? So here every observation stands for one particular customer. So customer ID will be the primary key for this, right? So we are defining this as the primary key here. Varchar, it can hold this many bytes or bits. This is age is an integer, grade is an integer. Then on running this particular table got created inside this database. We have already attached this particular database. So inside this table got inserted. Now when we do a select star from students, select star means select all the observations from students database. So we have created students. It contains nothing. So it is giving us a result here. The result of this particular command is this, right? It contains no data additional because we have not inserted data. We have only defined how the table should look like. We have not entered any data inside the table. That we will do next. So what we need to do in order to insert the data. So insert into students. So insert into, first step was create data. First step was create table. First step was create table, right? Second step is insert, create table, give the table name student, open and close brackets. Inside the open and close brackets, you need to define what is the field name and the data type is. Second step is insert into the table name, student ID, all these different fields you enter, what all fields you're going to enter into it, right? Same format, you enter the values. So values, write values and then define all these values within the brackets, right? This will insert these values inside the students table. All right. Now let's run this. Let's run this from students. So four rows got affected. And you have the student IDs and all this data that we have defined here has been populated into the students table. So we have successfully created our first table. Now, depending on what server, SQL server you are using, right now we are using, so inside this, we are using SQLite. Inside our Jupyter, in Jupyter, we are using SQLite 3, right? In MySQL server, we are using, of course, MySQL. These are two different servers, right? We are working with two different servers at the same time. Okay. Now in SQLite, you can see the table info using this particular command. So pragma table info students, you do this. This is giving us this info. What is the name of the field? What the type it is? What is the not null? I don't know what these values are. I don't care also. So this the data that we care about here is the name and the type. Okay, that's the table info that we care about. To do the same thing in MySQL database, you need to do describe students. We will do everything again in MySQL also. Okay. So this particular command of seeing the table info can change from database to database. Hope that makes sense. Now, once this is done, let's look at few variable types. Create a table in SQL. Right. So here, whenever you create a table, each of the columns that exists in the SQL table are of these types. It can be an integer, it can be a float, it can be a date, it can be timestamp, character. Varchar means that the variable length can change. Right. Char, when you define it as a char, it has an exact length. Like if character size is 4, it has a size 4 only. Varchar can change its size. Large amount of text can be text. And anything true or false is bit. There is also something called blob. If something called blob data type, anything that is unstructured, you typically write it as a blob. Right? We don't have an example of blob here. It's not commonly used also. Just saying just to let you know it exists. Okay, so these are the different data types. Now let's create one more table. Create another table called employee. These are the different fields. Employee ID, first name, last name, birth date, hire date, all these things. All this exists. Let's create this table. This will not input any data inside the table. This is going to be an empty table inside the database. All right. So we have created this. Now we have created two tables. So what we have done so far, let's come from the beginning, right? So let's come from the beginning. Let's quickly review everything that we have done so that everything falls in place. Now we saw the syntax earlier on, not needed right now. Then we saw We saw how to set up Python. You need to either install Anaconda or you can do this in Google Colab also. In order to do this, please enroll into the Python programming course. It's free. There, you need to see that these two lectures to set up Anaconda as well as Google Colab. All right. Once this is done, we imported this data set and saw how to insert this data set, the pandas data frame, into the SQL DB. We will see next. We will see how to create this DB. Next, we need to install the DB SQLite 3. This is needed to make SQLite 3 work, or this command to work. Do a small exercise. In this exercise, create. You can either do it in your MySQL Workbench. Better do it. You have not. I have not shown you any example on the MySQL Workbench so far. So try this out in your Jupyter notebook if you have already installed. Create a database called homework. All right. Let the database name be called homework. Create a database called homework. Then create, and you can do this exercise. We'll be sharing the recordings for this. You can do this exercise after the class also. I'm just spelling out the exercise. You can do this. You can pause it and you can do this. You do this also, or you can do it after the class. Then create an orders table in homework containing the following fields: orders ID, order date, quantity, customer ID, product category, and price. Just create these fields. All right. After you create these fields, insert the following entries. So it is in the same order. So this is the order. First is the order ID, followed by the date, then quantity, then customer ID, then product category, then price. The same order. Insert all these entries inside the orders table that is present inside the homework database. So that is clear. So this is your assignment. Now let's create a new table from the existing students table. Let's see how to create a new table from the existing students table. Now to create table, you don't have to follow the exact same thing. Earlier when we create a table, we are defining the schema here. But if you want to create a table from an already existing table, you don't have to define the schema. You can simply do this. Create table, right? Let me run this code. Create table called students underscore test as select star from table from students where, right? Let's go through this, what's happening. So instead of defining that, so here we have create table students test. So previously we did not have as. We started open brackets and closed the brackets and wrote down the schema, right? The column names and the variable types. If it was a primary key, we will write it as a primary key. Right? We will write this and then close it. This is how we created the table. Let's create the table schema. And then we next statement would be insert into table name, the students. Right, we did this and then inserted the values, isn't it? That's what we did. But now here we are creating it from an existing table. So create table, a new table name as here write your query. Instead of defining the schema, we write the query here. So select everything, star means everything from students, where this will filter out all the rows where the grade is lesser than 10. This is a condition, right? We'll see more of this later. It will execute this query and the result of this query will be stored inside this table. All right. The result of this query will be stored inside this table, basically. Once this is stored, so this is a run and we are selecting everything from select star from students test that is going to display out. So here, if you look at the grade, right, those grades that are less than 10 are being selected and stored in the new table. All right. Hope this makes sense. So that's how we create a table from an existing table. Show tables from an existing database. Now, different servers have different commands for this. I'm going to show you how to do this in SQLite 3. Then we will see it in MySQL also. So here, database, typically a database can contain a lot of different tables. A lot of tables can exist. To start, if you have the access, if you have all these things set up, if you are able to run it, please run it. You can run it later on also. Anyway, I'm going to be sharing the videos. You can run it later on after you receive the recordings for this class. All right, so it's perfectly fine. You can do it now. You can just pay attention to what I'm doing here right now and then do it separately also. But please pay attention. That's very important. Now, from a given database, so a lot of tables are existing, right? Now, this is another problem. If you are not having this knowledge and just starting to work on SQL, you'll find it a tough time to locate what table is present in what databases. You need to know what are the different databases that exist, and within each of the database, what tables that exist also. And we will see both of that. So, to see, so here select name from SQLite master where type equal to table. If you run this, it will tell you. So this is a SQLite specific program. SQLite master is a table that exists in SQLite by default, the database by default. This is not something that we created. It already exists. This table contains the names of all the tables that exist. All right. Now here instead of this, let's see the contents of SQLite master. All right. Let's see the contents of SQLite master. So if you do this, so it has a sample df. It has the name, select, do a star. So it has the type, table name is the name of the table name it is giving, then root page, then SQL query for that. Right? Multiple information is present. Now we are interested in where type equal to table. So wherever the type was table. So this is an index, this is a table, this is an index, and so on. Wherever the type is table, we are interested in seeing only those items. Isn't it? So here we are getting all the different table names alone that is present. So when we are running this query from within this database has been loaded, right? So whenever we are working in SQL, all the queries are corresponding to a particular database we are running it on, right? So select name from this particular table. And this every database contains this table. SQLite master, every database contains this table. So we are seeing all the tables. To do the same thing in MySQL databases, you do show tables from database name. That's it. All right. Now, how to copy data from one table and put it into another table? We have something called an insert into command. So insert into, what we are doing here is insert into students test. Insert into this table, this query, insert this query, the output of this query into this table. Right? That's what this does. So we are basically doing, we are taking all the records from students again and putting it into students test. Now if you look at this, some rows earlier we had already copied, right? So some rows should duplicate. So Jane is getting duplicated and Jack is also getting duplicated. So these 4 rows got added, right? These 4 rows got added into students test. So that's as simple as that. Let's do one more. Insert into students test 2, the same thing. Now here, look into this. It is giving out an error. Why? Because there is no table called students underscore test 2. We have not created such a table. It does not exist. So it is erroring out basically. All right. Now, in order to make this work, you need to first create students test 2. So we are creating again students test 2, recreating it again, and look at the contents. We have 2 rows here. Now, so we have the 2 rows here. Now, what happened? Okay. Now we run this. Inside this SQLite master, we can see students test 2 exist. So this table has been created. We have already seen the contents of this in order just to make sure it has been created. That entry has been added to SQLite master by default, by automatically. Now delete command. You can. So there are 2 things. Deleting an entire table is one thing. Deleting certain observations in a table is another thing. So delete from, write the table name, and based on what you want to delete. Suppose if you want to delete all the observations where the grade is equal to 10, you can add a where condition and specify that condition. Right? If you want to delete the entire table, that's a specific command called drop table. Just do drop and the table name, the entire table will go off. Now, if you do this, see the output of students test. Wherever the grade was 10 earlier, we saw the contents of students test. Students test. So these observations, right? 10, 10. These two are gone. I hope this is students test only. Okay, and this is test 2. Under test 2, we never inserted grade equal to 10. So let's do grade equal to 9 itself. To do this, those two observations where the grade was 9, those two observations are also gone. So students test 2 does not have anything now. Let's create students test. I mean, let's put some data inside students test again. Right now, students test should exist. Zero rows affected. Students test 2. Let's see if it exists here. Students test 2 exists. Create table student test 2 where grade is lesser than 10. So students test 2 already exist. So we need to just insert the data here. So now students test 2 is created, right? So this did not run. So this got errored out because this data is already existing, right? So we just need to insert the data into students test 2. Now if you go back here, and run it, students test 2 exists. Now look at this. After removing the rows where 9 grade equal to 9, you have these 2 rows existing. Hope that's clear. All right, and where a grade equal to 9 and age equal to 15. So grade equal to 9 and age equal to 15. No row exists, so this should not make any change here. All right, so in both of these rows, this condition would not satisfy. That's okay. Now to delete the entire table, we have already covered this. To delete the entire table, we simply do a drop table, right? And write the table name. That entire table will go off. Okay, so let's run this. Students test 2. This table should have got deleted right now. It will give an error because it does not exist anymore because we had deleted. Okay, wait. Right now we have deleted it. Now if you run it again, this is erroring out. No such table, right? Operation error, no such table students test 2 because this has been deleted out. And if you look at the content of this table, students test 2 has been deleted also. It's been completely removed. How to update the existing records that is already present in the table. Okay, so to update the records, you have the update command followed by students, then set grade equal to grade into 10. Like, so what are this? So this is a new column. But these are the changes that we are going to be making. So use the set command, do all the changes. First, filter first. Okay, it will filter all the records where the first name equal to Jane. For Jane, we are going to multiply the grade by 10 and increase the age by 2. On doing this, should affect only the Jane row. Only for the first name equal to Jane. We have multiplied the grade by 10 and added the age by 2. Increase the age by 2. Right? So this row alone got updated. Set the database as Sakila in this. Make sure you are doing this in MySQL Workbench. So we will the same set of activities that we just saw in Jupyter Notebook, we are going to repeat in MySQL Workbench after this. Now, set to use inside MySQL Workbench, set to use the database as Sakila and update the table called film inside Sakila database to increase all the values, the rental duration by 5 units. So there's a column called rental duration. Increase the values of rental duration by 5 units. So what I mean by that is, let's go to the MySQL Workbench now. It's good time to get into it. So now if you go into Sakila database, here, the name of the database we are dealing with is film, right? Inside film, know this, inside film. So if you do a select star from Sakila dot fill. Right? To run this, select the entire thing, and if you click this button, the selected portion will get run. All right. So this is the data. So it is printing out the data here. This is the convenience of using the MySQL Workbench. Right. So this is the data. Here there should be something called rental duration. Increase this value by 2. That's the assignment. Right. Increase this value by 2. All right. Now let's see how to work with MySQL Workbench. Let's see how to do that. Now we will do all the operations that we just did with Jupyter Notebook, right? Jupyter Lab. All those operations we are going to be doing with SQL Workbench. Now, first step, let's create a database. So here right now, you need to be in Schemas tab, right? You need to be in Schemas tab. Let me quickly check. Let me quickly check this. So here, okay, inside Schemas tab, you can see it contains the Sakila database. Let me refresh this. It contains Sakila, it contains this, it contains world. Right now, I hope you can still able to see this. Inside Sakila, the database that is in bold color data, right? That is the database that this is going to be using. This currently active database will always be in bold. If you want to change the current active database, you need to double click it and it will change the active database to that particular database. So here now the active database has become world. And if you want to go back to Sakila, just double click on Sakila. That database is now active. Right? That database has become active. Now let's do all the activity. So first we want to create a database. Let's create a new database called testdb. All right. The code has run. You can see that the code that we just executed here in the bottom, create database testdb, is right at the bottom. Right. The database has been created. If you refresh this, testdb is occurring here. It's appearing over here. All right. It's in very small font. I'm not able to increase the font size. Please excuse me. So here you see the new data set. Now you can drop the data set that we just created, right? If you do this, if you run this again, drop database, that has been executed now. All right. On dropping this and refreshing, that particular database is gone. TestDB is gone now. It no more exists. So let's recreate it back again. Create database, and testdb should appear here. Yeah, testdb has come. Now inside this, let's create a new table called students. So here we are writing create table. We are explicitly stating what is the name of the database this table is presented. Okay, let's do this experiment. Let's run it without this. Okay, let's run it without this. Run this. All right. On running this, create table students. Okay, this got created actually, but we created the table, but it got created where? Is it created in testdb? If you look at the to look at the tables, right? You can use show tables test underscore db. All right. To run it, Control Shift and Enter. It will run that particular cell. Show tables testdb. You have an error. Check the manual corresponding to for the right syntax to use. Show tables. Run this. Okay, it shows the tables in Sakila. Okay, now double click this, and then run show tables again. Run show tables again. Now tables in testdb, nothing exists. Why? Because when we ran this, Sakila was already double clicked. So that table students got created inside Sakila. So if you double click this, activated Sakila, now run show tables. Inside this, there should be a table called students. There should be a table called students, and this is present over here. Right? So that is present over here. To create the same table to here, we can explicitly, instead of changing the database, we can explicitly say, okay, test underscore db dot students, and run this whole thing, Control Shift and enter. It ran the code. Now, if you look inside this, let me refresh this. Now, if you look inside this, the tables contain students, right? So students is occurring inside test DB. All right. Now you can drop it also. Just for the sake of it, you are dropping it. Test DB does not contain any table. Let's create it one more time. Test DB dot students. It's created now. Refresh it. Sometimes if you don't, it might not update here. On refreshing it, it will update. The students has come here. Right. Now, if you try to retrieve the data from students, nothing will be there because it's empty, right? The table is empty. Now, inside insert, we are going to insert some data inside students. Okay. So we are going to insert these 4 rows. We have already run this code in Jupyter Lab. We have inserted this. Now we do retrieve all the data. Right. These 4 rows have been added to students. The test DB dot students. This data is present. Okay. Now we are going to also create employees data inside test DB. Another table. So it should appear here. Refresh this. So employee has come. Right. But no data is present. We have not entered inside this. Entered anything inside it. So let's run describe students, right? So these are the different data types present inside each of the inside students, and describe test DB dot students. Both are the same actually. Since okay, when we did now here. So here, when we did describe students, Sakila is being created, right? Sakila is active. So when we run this, it refers to the students table inside Sakila. Right? This table also, inside Sakila also, students table is present. Right? When we run this schema it shows is from a Sakila table, Sakila database. Whereas if you want to get the students inside test DB, right? You need to run this like this. Describe test DB dot students. Even though Sakila is the default, it will show from test DB dot students. This database, this table. First one is how to select specific data. We have seen the select star statement so far, right? So we run the select star. It will retrieve all the rows from the data. If you want to select specific columns alone, say specific columns alone, inside after select, write the column names that you want to select alone, only those columns that you want to select, and then run, right? Only those columns will be returned. As simple as that, as direct as that. Right? Now, if you want to select few rows, right? First name, we select the first name and last name, but we want to select only those rows where the first name is either Jane or Jack. Either Jane or Jack. Only these 2 rows we want to select. Means you can add a where condition where first name inside the brackets pass in the values that it can contain, allowed values. So if you run this, it will return only Jane or Jack. Now if you want to do the opposite, select everything except Jane or Jack. How will you do that? You can, instead of doing an in, you can do a not in. If you do a not in, you will get the John and Jim here, right? Except Jane and Jack, everything else is coming here, right? Select all where the last name starts with D, right? So here, last name like D percentage. So we will see more about this wildcards. We call this as whenever there's a like statement, it always deals with wildcards. So this pattern, what it means is the percentage symbol here represents to one or more value, any value, it could be any value. It just needs to start with a D. Anything that comes after the D, you can abstract it and put it as a percentage. So this is a general pattern for everything that every word that starts with a D. All right. So we are using this command to get all the names where the last name starts with a D. How to write comments in SQL? Very straightforward here. Very, very straightforward. If it is a single line comment, just start with a hyphen. If it is a multi-line comment, put it inside slash star and then close it with a slash star again. All right. So this is how we write comments. Very straightforward. Anything that you write here inside this comment, that will not get executed. So let's run this, right? So this entire thing got executed properly, even though some English is present here, right? It got executed perfectly because these two are treated as comments. Perfectly fine. If you want to limit the number of rows returned from a query, so this will return all the rows. If you want to get only the first three rows, only 3 rows from this, set limit equal to 3, it will return only 3 rows. In certain databases, instead of doing limit equal to 3, you will write top 3 instead of limit equal to 3. In SQLite, we don't use this, but certain databases uses another command called top 3, and what top 3 star from student test means it will return the first three observations. Okay, so this works. So limit 3, only 3 observations is returned here. Now there's another statement called offset. So here it will leave out these 2 rows. Same command here. We have added additional offset of 2. So it will return 3. Limit is still 3, but it will leave out the first 2 observations and print the next 3 observations. So it will leave out. So here effectively it will leave out the first 2, Jane and Jack here, and the output should start from John Doe and so on. All right, so let's run this and see the output. So you have John Doe and then J Doe and then Jim Beam. All right, so that's how it works. So you have John starting with student ID 1, right? This is also having student ID 1. So that's the same John. Select distinct. How select distinct works? Now, if you look at this, you see the specific questions. No, we cannot use hash for SQL moments. SQL is for Python and R programming language. All right. Now, select distinct. Okay, Hamza, you have asked about, please describe about primary key. How can we create if possible? You can define the primary key at the time of creating the schema of the table. We have already covered that one, Hamad. I'll recommend you to watch the recording of this session. We'll be sending out in a couple of days. Please watch that and you will get to know that. Otherwise, we'll be again repeating the same thing that is already taught about. Okay. Now, select distinct. Identify and delete the duplicates in the data. Right. So, if you do a select star from the data, it will return all the rows. If you do a select distinct star, it will return the unique columns from the entire data. Right. If you select a specific column instead of doing a star, select distinct student ID, it will return all the distinct student ID. So here, let's do this. Let's run this and see. So this is giving all the observations here. Right, all the observations here. Select star. Select distinct star means if there are any duplicate observations, if the entire data is getting duplicated. You see here the 4, right? 2 and 4. Jane Doe, the entire row is the same as the first and the 4th row is exactly the same. The second and the 6th row is exactly the same. Right? We don't want that. Now, if you want to remove that, do select distinct star. It will give you only the unique rows. If you want to get the unique distinct values of a particular column, you select distinct, the name of the column, and then you will get the output. Then where condition. We have already seen SQL where previously. The where condition typically comes after the from statement. So after the from statement, you will write the where condition. This will get executed first. Right? The where condition from this data, the where condition will get executed first. It will filter out all the people whose grade is lesser than 10. To do the filtering and then do any other activity, then it will do select the column that you are asking for, and then on that you will return the output. Right. So here, running this is giving all the values, all the rows where the grade is less than 10. You can add multiple conditions, either grade less than 10 or age greater than 14. This will work too. This will also work. Both conditions should satisfy the output. If you want specific student IDs, you can do, instead of using a greater than or lesser than symbol, student ID in these values, only those values will be returned. 2, 3, or 4, only those student IDs will be returned. Now the exercise, again an exercise on this. Try the following in MySQL Workbench on the Sakila data. We have already seen this data, the Sakila dataset. From Sakila.film, select only the film titles and description with rental rate more than 2.0 and rating is PG. So Sakila.film contains various film titles, names, and rental rates, and the rating equal to B. These are various columns. Besides this, some other columns are also present. So from this data, select only those film titles and description, only 2 columns. Film titles and description, only get those 2 columns that satisfy these conditions. That is the first exercise. Second exercise is from Sakila.payments, count how many payments more than $5 has taken place. Count the number of payments where more than $5 has taken place. So this is the exercise. We have some notes here on how to access the Sakila dataset if you don't have access. If you somehow do not see the Sakila dataset or database inside MySQL Workbench. Now let's understand SQL order by. This is for sorting the data. Right now we have already seen how to select the data. After the statement, after the from statement, you can do the order by statement. Select the names of the columns based on which you want to order the data. So order by grade equal to grade ASC means it will order the data based on grade in ascending order. Based on grade in ascending order. If you want to grade in ascending and age in descending, you can order by both columns. Like first it will order by grade, and then within each value of grade, the age will be in descending order. Right, so this will rearrange where 9999 it will be there, but Jack will come first and then Jane should come. Let's see this. So 9999. Okay, this is in ascending, right? So Daniel comes first and then Jack and then Jane. First name only, right? Jack and then Jane. So 15 and then 14. Likewise, within 10 also 16 and then 15. All right. Even though 16 is greater than the 15 value, it's appearing here because we ordered by grade first. So based on grade, it will get ordered, and within each value of grade, the age will get ordered. That's how order by works. Let's now see how to use group by. Group by is like aggregating the data based on certain other variables. Well, for example, say here it's a nice example, direct example. So here we are grouping by student ID and first name. So for every student, what is the average age and the sum of all the grades that they have received. So we are selecting these 4 columns, right? Student ID, first name, average age, and sum of the that particular column for that particular value. So here, if you look at this, student ID and first name, right? Only one occurrence will be present based on student ID and first name. Only one occurrence is present. The average is computed. The average for age and the sum of the grade is computed. Let's understand the having clause. This is a very popular SQL interview question. Very, very popular SQL interview question. What is the difference between a having clause and a where clause? Because here having also it's appearing after group by, right? Where occurs before group by here. Notice the difference. Having after group by, where before group by. All right. The difference between where and having is where is for filtering the data before the aggregation happens. Here we are aggregating the data. So we are aggregating grouping by student ID and first name, computing the average age and the sum of the grade. But we are doing this only for those records where the grade is lesser than 10. Right, in the original data, wherever the grade is lesser than 10, we are taking only those records and doing this grouping. Right, whereas in having, we will do the grouping first. We are not doing any filtering here. There's no where clause to filter out the grade lesser than 10. There's no clause. Right? So it will do the grouping on all the records. After the grouping, here we are storing the grade as, we need to store it as a different name here. Okay. Store it in a different name grade. And that new name, suppose you don't store it as grade here, that will cause a problem. Okay. Store it in a different name. The new name you can use in the having clause. Now this one will happen after the aggregation or the grouping is done. Right? So that's a very important interview question. You need to understand if you are setting for a SQL interview question, this is a typically asked question. Right? You can definitely expect this question in SQL interviews. The final topic is joining datasets. Now you have 2 datasets. You have dataset A, you have dataset B. One of the columns in dataset, both of these datasets is common. Right? You have 2 datasets, 5 columns here, another 5 columns here. Right? Different set of 5 columns, but one of these 2 columns is the same. These 2 columns is the same. Say, let's say this is customer ID in these 2 columns, right? Customer ID is the same. We want to join this data, the new data, to this data as one single table, based on this customer ID column, common column, right? That is what joins is all about. That's what joins is all about. There are 4 different types of joins: inner join, outer join, left join, right join. 4 primary, there are other types of joins also. Primarily in SQL, there are 4 different types of joins. Inner joins means, let's take the rows. Right? Let's say this has 3 rows. This one has, so this has 4 rows. This one has 5 rows. Okay. This table has all the rows that this one has. This table, right hand side table, has, for you it's left hand side probably. This one has all the rows that this table has, left hand side table has. Okay. Now we want to join them both. And inner join means you take only the common columns and join them both. That is inner join. Outer join means it contains these 4 as well as all these 5. No table, no record will get missed out. Suppose if this table has 5 and this table has 4, it will still have all the outputs. That is outer join. All the rows from all the records, all the tables will be included in the outer join. Getting me? Now suppose if this is having 5 rows, this has 4 rows. Right hand side, this has 4 rows, this has 5 rows. You do a left join, this is left for me. Okay, this is left for me. You do a left join, we merge it together. The data point that is missing here, right? This data point, the index finger or this little finger data point is missing here, right? That data point will be null value. It will get left joined into this one. The right join is the other way around. If this is having 5 rows, you're joining like this. This will get attached here, and all the rows from here will be present here. All the rows from the right hand side, my right hand, will be present when you do a right join. The left hand side data will get attached to the right join. So that's the whole funda behind it, right? So here, these are 4: inner join, full join is the outer join, left join or the right join, left outer join or right outer join it's also called. Right? So inner join means only the common columns. Outer join means everything. Left join means all the records of the left hand side table will be included. Right hand side means all the records from the right hand side table will be included. All right. Now here we have the customer table. Let's implement this. We have so this is how it looks like. 4 records, customer ID and name. Then we have the orders table. And this is how the orders table look like. Order ID, customer ID, and product name. Right. Then we have so we have 2 tables. We have the orders, we have the customer table, customers, and orders table, orders. Okay. Now if you do an inner join, say select orders.star means all the records from orders, customer.name. We take all the records from orders, only the name column from customers, right? So from customers, we do an inner join with orders on the common column between both. The names of the column can be different in both of the cases. This could be called customers also, let's say, right? Then customer. If that is the case, instead of writing customer ID, we will simply write it as customer. Right? So this will do an inner join. Let's see the output of this. So here, so 1, 2, 3, only 3 order IDs is coming. So this is the order table, right? 1, 2, 4, and 5 customers. So these are the customer IDs. In customers table, we have 1, 2, 3, 4. Whereas in orders table, we have 1, 2, 4, and 5. Right? So only the common columns will be added. So only 1, 2, and 4 is common between them. So only 3 rows we are getting. If you do a full join, where is the full join command? Okay, this should be Python code. Should be said. If you do a full join, all the records are coming here. Right? All the records are coming here. Wherever it is null, it will throw a null. That's fine. All right. Likewise, left join means all the records on the left hand side table will be present. All the records from left hand side table. Left hand side table means customer, right? Customer will be present. Right? Whereas right join means all the records on the right hand side table will be present. Right hand side table, which is orders. So if you look at the orders table, you have In orders table, you have apples, bananas, grapes, and oranges. In right hand side, right join, apples, bananas, grapes, and oranges. All four are present here. Finally, exercise. Try this exercise out based on circular data frame. So create a new table that contains these fields. Make sure none of the films get missed out in the result. Right. So you have a film table and then film actor table. You need to add the film actor name, which comes from the film actor table to the film table. So these four rows: film name, release year, rating, rental rate. These four rows come from the film table. Film actor name comes from the film actor table. Right. Merge these two tables to get all these five columns. So that's the exercise. What is the average rental rate for each film actor is the second question. All right, try this out in MySQL Workbench. SQL DateTime Operations. SQL DateTime Operations. Now, how to do this? So, DateTime is actually a complex data format. It contains year data, month, date, minutes, seconds, hours, and everything. And if you are representing it as a string, right? If it's represented as a string, it can be a problem to do some arithmetic on top of it. Suppose you want to get the month of the year or day of the week, something like that. You need to treat the date as a separate date format, specific date format. You need to handle it separately. It cannot be handled as a string, basically. Right? SQL supports various different types of date time or string date and time related operations. You can do all these things, extract the date and the time, extract year, months, day, all these things. You can add a day to a date, right? All these things you can do. So we are creating some data first. To create it, I'm defining the higher date as a date time. So this will create the schema and inserting these values into it. And this is how the data looks like. Extract the date and date time from this. Use the date function, date command, pass in the date and store it as a new column here. So here, this output gives us the higher date and the time separately. So this is higher date time. From this date and time are separated out as two different columns. So extract the year, month, and day. Right, you have the strf time. Right, you can format it to get the respective year and month and so on. Higher year, higher month, higher day. Very straightforward. Likewise, you can use the same strf time command to get the hours, minutes, seconds also. Hours, minute, and second. Likewise, you can add date, right, from higher date, date time, higher date. You can add 10 days, subtract 1 month, add 1 year, do all these things and store it separate columns. All right. Very straightforward things. Just a knowledge of this is sufficient right now. You have current date, current time stamp. Right. All of them are stored as predefined constant values, whatever the time is as of now. Yeah. Then you have the values to calculate the date differences between two different dates. So the number of how many days exist between now versus higher date, right? That will be the number of days. You divide it by this particular value, that will be the number of months. You divide it by 365.25, that will be the number of as date into months. Let's run this. This is years. It should be this should be years. Right? That is so this is in days, months, and years. Let's now understand the null values. Every other data set in real life, you can expect null values to be present. And you need to be able to handle those null values. You want to replace, you might want to remove those rows. You might want to filter out the rows that contains null values, or filter out certain rows in certain columns alone that contains null values, right? Or you might want to replace those null values with some other value. Those kind of things. Let's see how to do all those activities. So these are some of the common activities: filtering null values, filtering not null values. There's also coalesce function. We'll see how that works. Coalesce and if null are serves the same purpose of replacing null values. We will see the difference between them also. Now, first step, filtering null values. So select star means select all the columns from this particular database. We just created a copy of sample df and stored it under sample df2. Select everything from all the columns from sample df where this particular variable var1 is null, right? So select only those rows. If you see the output and go here, you see this particular column var1, all these values are null because that's the condition that we have given here, isn't it? Now that has returned us all the records where var1 is null, right? That's one example of how we can filter out null values. If you don't want null values, you want all the values that are except null, right? So you do, instead of is null, you do is not null. Add a not here. So whenever it is not null, all those records will be included. So var1 has returned all those rows where var1 is not null. Hope this is clear, right? Simple step. Simple things. SQL is very easy to understand, folks. We are going to be taking it in very simple steps. Progressively, we will look at more and more complex topics. We are still in the very easier parts of the Excel, and these are some of the most, like 70-80% of your writing code in Excel will involve these commands only. All right. You will definitely be facing situations where you need to be able to write complex queries. That also we will be covering, but we will get there in steps. All right. Let's take it in a steady pace so that nothing gets missed out. Everything will make sense when you get there. Right. So next command is coalesce. Now here you have, let's say you have two columns. All right. Let's say you have two columns. Let me call this as column 1. This is column 2. All right, and you have various values. Now there are some missing values here. There's a missing value. Here there's a missing value. Let's say. Now what can happen is this missing value. Typically, what you would want to do is this missing value you would want to replace with some constant or some value. Say you want to replace it with a text called missing, or you might want to replace it with the value 0, something like that. There might be some rule that you might be having, right? So that you can do. Using coalesce. You can also do, what you can do is, if this is missing, take the value that is present in some other column. If this is missing, take the value from column 2 and put it here. This is also possible using coalesce, right? Even now, if this is missing also, right, then there might be some other column in the data. Let's say there's another third column, and this value is present. You can replace this value into this. You can do this for n number of columns using coalesce. That's the purpose of coalesce. Very versatile function. Both coalesce as well as if null serves this purpose. Let's see the syntax, and let's also finally see the difference. Now see here in var3. So select all the columns. Then we are creating a new column using this command, right? And we are naming it as var4, right? Here, take the value of coalesce var3 comma missing means take the value of var3. If something is missing, replace the missing values with this particular text, right? So here, if you look at the output under var3, if it is missing, this is missing. It's none here, right? Since this is none, we are doing this and applying it, storing it in a new column called 4. So this is the entire data. So select star will create all these columns for you, right? The next command here, coalesce this part, will create this particular column, var4, right? Now here, if this is missing, or if it's a null value, replace it with this particular text here, and then create a new column called 4, and that's what we have done. That's what has happened. A similar function, a similar objective is served by if null function. The only difference is exactly the same as the coalesce function. Only difference is you cannot have multiple columns being passed here. It takes only 2 arguments. So this is the column that you want to refer. If this is null, replace it with this particular value. That's what if null does. Right? I think it works for if you have a column called var2. This works also. I think so. That, yeah. But you cannot have another column, third argument it does not take. Say you want to, if var2 is missing, take from var1, you cannot do this. All right, or so only two arguments you can pass for if null function. All right, so this makes sense. This is one other example of how you can use this if null function. Very straightforward, very straightforward. So you have you're selecting the name column. If var3 is null, use the values from var2 and store it as var4. So you have in the output, you have the name and the var4 columns alone as the output. Okay, folks. So hope this makes sense. So what's the difference between null, is null and coalesce? Is null and not is null, if null. If null and coalesce. The difference between them is coalesce can accept multiple arguments to replace the null values from. That's the only difference. Now let's do 3 exercises where I want you to you can try out these exercises. Is go to dbfiddle.com. Go to dbfiddle.com. If you are in front of a computer, please open up your favorite browser, and go to. Let me type out the URL here. You can try this out in your Jupyter notebook. If you are going to be, right now, if you are watching the recorded version of the video, you can open the Jupyter notebook that is present inside your resources directory. You can open that and try this out. Alternately, you can start a MySQL workbench. So we had installed it in the previous class. Open your start, go to MySQL, open this workbench, copy and paste the code that I'm going to be sending you shortly. So this is the code, right? This code, you can paste it inside your MySQL workbench. I'm not going to be using this right now. Start your local instance. Set the password. We had done this setup in the previous class. All right. So here, I'm just showing you this is an option. If you are watching it in a recording mode, you can do this also. Right. Start this and paste the query that I'm going to be pasting in the chat. This query that I'm pasting in the chat is available inside the resources folder. Inside resources, this is old one. This is the resources. Inside resources, you should have q1.sql. I'm going to open this up. All right. Remove this off. And I'm going to do select all. I'm going to select everything, Control A, Control C, right? And I can either paste it here. I'm not going to be using it now. I'm pasting the entire thing here. The comment is not needed, right? We can start running it like this, right? Either you can do this. I'm going to close this off. We are not going to be doing this. Either you can do that method or go to dbfiddle. The only thing is this is not controlled by me. dbfiddle is a completely third-party website. The chances are by the time that you're watching this, dbfiddle might still be online, right? If it is not online, you can try the whole thing out either inside your Jupyter lab, or you can try the whole thing out inside your MySQL workbench. Both of it should work. Just for the sake of convenience, quickly you can open up a browser and try the code that we are going to be doing now. All right. So what I'm going to do, I hope I have copied it. Let me do the copying one more time. Control A. Let me not copy these comments here. I'm going to copy everything from the drop command. Right? I'm copying everything from the drop command. So Control C. I'm pasting this code, all this code in the chat. Control V is not taking the code. Control C and paste. For some reason, I'm not able to paste in the Zoom window. I think chat will take a limited number of words, probably the case. I'm not able to paste it here. Let me see if I can attach this file. How do I go here? One level. Trying to figure out how to paste this. Just a sec, folks. Let me see if I can drag and drop this. Yeah, I think it is sending now. I hope you are able to download it. Let me try the first part. Let me try if this works. Half and half code as suggested by Amrita. This is the first part. Yeah, it's going in. Thanks for that, Amrita. And the second part is this part. Control C and Control V. That's not working, unfortunately. So let me do it this way. So I'm going to take first half of this, paste it here, right? There's a comma at the end, right? The very next line, I'm going to paste it as a next chat. All right. So this is the entire code. I have given you the files. I've given you the codes also. Hope you're able to access this. Now I'm going to copy and paste. Can you please confirm if you're able to open the file and you open the file or copy it? Either ways, you have access to the code, right? Now I'm assuming that you're having access to the code. If you are facing any trouble, please raise it in the chat. What you need to do next is, once you are in DB Fiddle, you should be seeing something. You might be seeing an empty screen like this. Okay, I'm going to refresh this page completely from scratch. So you should be seeing this empty screen. I'm going to paste the entire command that I had copied. Right? This is the entire command. Simply after copying this, simply run this. On running this, there are no results to be displayed. It says no, it has run it, right? It has run it, but no results to be displayed. What it has done is it has created a table named customer. It has all these fields: customer ID, store ID, first name, last name, email, and all these things. It has all these fields and inserted these values into customer. So this table called customer has been created. All right. So this is your base. Can you please confirm if you have, if you are able to create the table called customer in DB Fiddle? Once you are able to do that, please write confirm on chat so that I know that you are following along. If you are facing any trouble, please write the difficulty that you are facing also. Thanks for confirming, Salman. Anyone else facing a problem? Could not open it. Why DB Fiddle? You can use anything, Salman. I think Anil, right? You can use any server, any place where you can write SQL queries. You are not restricted to DB Fiddle, Anil. This is just a place where you can just type a URL name and start writing SQL code. That's the only reason. Could not open it. Furman, can you please elaborate on your problem? First, I have to create a database first. I hope you are working with DB Fiddle, Salman. If that's not the case, you have to create a database first. Yes, have to create it. That part we had covered in the previous class. Alternately, you can simply type to create a database. If you are inside MySQL Workbench, you need to first write create database, name of the database. Right? That's all. It will create a new database completely. Kafil, I am typing one by one. I said it is not a Workbench file. Where are you typing this, Furman? You are trying it in MySQL. If you are trying it in MySQL, please, I'd recommend you to try it with DB Fiddle. Okay. Now, assuming that you are working in MySQL, can you please confirm what you are using, Furman? Thanks for confirming that. Great. Can you copy WhatsApp? Can you copy code to WhatsApp group? Not sure what group you are in right now. Unfortunately, I'm not able to. I'm connected to a different WhatsApp in my computer, Dhanushri. Let me see. Just a sec. If I'm able to WhatsApp group. Unfortunately, this file is not in my phone, so I don't have a way of pasting it. Let me try to understand what problem are you facing, Dhanushri. If you can elaborate, I'll try to help. Salman Hussein, I will spend 1 more minute on this particular topic, guys. Topic, folks. We will move on from this after 1 minute. MySQL, you are using MySQL. Then you will have to create a database. Then you need to write. So if you're working in a database, right, inside MySQL, then explicitly write the DB name, whatever DB name that you had created, right? DB name dot create table. Then write DB name dot customer. That should work. Here also mark DB name dot customer, whatever DB that you had created. You can create a DB using create database DB name, right? That you can create. I hope we have this command somewhere in the previous class. Create a database we had covered. Okay, we showed it in the demonstration. If it is not there in the notebook, inside the videos, they should be there in one of the parts. So here, this is the setup part. So this is the screen that you would have got, right? You need to click on schemas. So this is your MySQL Workbench. Click on schemas. You should be able to see all the databases. Select the database that you are. Double click on one of the databases to activate it. So whatever queries that you write will be, whatever tables you create or queries that you write will be referenced to any table that is present inside that database. All right. You need to click on schemas here in this screen. Click on schemas and select one of the databases that is already there. Right? If it's not there, you can create a new database using create database command. Okay, fine. We have spent enough time on this. Let's move on. Now the question for this session is, right? These are the 3 questions. Attempt and solve these 3 questions. Let me paste these questions on the chat. The first question is select rows that have no missing data. So from customer table, select all rows that does not have any missing data. That's the first question. Second question is replace missing values in the age column with the value minus 999. So in this data, here, the bottom, we have an age column here, right? The age column comes after email. So everything after the email cell, right? The email field is the age. So the age is 15 here, 16 here, and so on, right? The question is replace all the missing values in age with the value minus 999. All right. The third question is replace missing values in the create date with the value with create date column with the value from last date. All 3 questions are based on missing data. What you need to do, let me solve this first. So here, so this is the query, right? So this is an answer to the question. So I'm going to solve this for you. I'm going to go here and paste the query on the right hand side. Right? Don't paste the query on the left hand side. Paste it, whatever SQL query that you are going to be running, paste it on the right hand side and click run. Test customer doesn't exist. I never referenced test customer. Unknown table DB name. Let me remove this. Let me remove this also and run. Amrita, I see your query first run the schema. How do you run the schema? The run command, right? Or are you referring to something else? So in where we have to type. And then I run this. Okay, so that gave the results. So left-hand side part, we create all the databases. Any database update related statements we make in the left-hand side part. Any query that we want to run, we make it and we write those queries in the right-hand side part. That's how this is split, right? So left-hand side, we are creating the schema. So create table, this is the table schema that we have created. Then inserting values into the table and running the query here where store ID is not null and age is not null, right? So specifically, we are looking at store ID, none of these values are null, and age is also not null. None of these values are having null. And if you want to get the count, right, instead of doing, this is one of the questions that we saw, right? So instead of doing this, select star, you can do select count star. All right, so this will tell us, let me comment this out. Okay, this should not be the comment. Now, if you run this, this should give you the number of records, valid records that satisfies this query, that is 12 records. All right. Harish, I see you pasted some code where store ID is not null. Great. This will ensure that none of the cells, none of the columns will have missing values. Here in my solution, I know already that only these two columns are having null values. Because of that, I have put only these two columns. Ideally, your solution is a better solution actually. So I'll copy this, Harish, and paste it here. So this is a more complete solution than what I have actually written, right? So let me run this. And this will ensure that none of the values present in the table will be having an error. Okay, let's move on, folks. So next one, replace missing values in age with 999. All right, so this is the answer to this. I'm going to go back to the table, Control A, Control V. Instead of limiting to 6 rows, I'm going to run everything. All right, and run. It's running the query and has given it out. Now here we have to look inside the age column. I'm creating a new column called new age. So when the age column, I have dropped here. I have not included. I have retained the new age column. I can retain the age also. Age here, and then run this. Right. So if it is null here, the value is null here. Whenever it is null, the new age column has the value minus 999. Yes. So that's the solution for this. The next one, we move to replacing the missing values in created with the value from last date. So it's very simple, very direct. Level 1 questions. All these are level 1 questions. So some of the direct, most commonly used ones. So let me run this. So here I'm using koalas again. Create date. I'm not able to increase the font size. So let me try to increase it if it is possible. Okay, this is better. So here, koalas create date. If create date has missing values, it will take the value from last update and store it as create date again. So let me run this part, and that should give the output. Now in create date, wherever it had a missing value, it would have replaced those missing values with the value from last update. So any cell where you are seeing the last update and create date to contain the same value, those would have been missing in the first place. So this would have been missing. Has taken the value from last update and placed it over here. I see Salman has raised hand. Salman, let me allow you to talk. You can unmute and speak if you can. If you are in a position to speak. You have a question, Salman?
Yeah, hello. Can you hear me, sir?
Yeah, I can hear you well, Salman.
Yeah, so I have one doubt, sir. In select, sir, why to write the remaining column names? Like instead of like we have to replace the names for age and create date, right? So then why to
Yeah,
write that unnecessary?
it's not needed actually. This is just for sake of completion. So you can remove this also. It's not needed. I just retained it from the previous query. Okay,
Okay,
this also again remove this. This is also the first statement is also not needed, but we did it in the previous one. So
okay, got it, sir.
it'll
Thank
be
you.
fine. Okay, so let's run this. Now you have new age, created date, and last update. Yeah. Operators part 1. So the next part we are going to look at is operators. Let me zoom out a bit. This section is straightforward, folks. If you are already aware of what the and, or, and not operators is, it's very direct. So in SQL, whenever we are writing queries, especially during the where query, you might want to do, okay, I want this condition to be satisfied and also the other conditions to be satisfied. Only if both of these conditions are satisfied, return only those rows, right? Only those rows that can satisfy both of these conditions. If that is the case, you will want to use the and operator. If it is satisfying either condition A or condition B, you can use the or operator, right? Not as a negation. If this condition is not satisfied, if you want to write such a clause in your where statement, you can use the not operator. That's all there is to it. And here is an example. So select star from sample df where gender equal to male and salary is greater than this much, right? Only if both of these conditions are satisfied, it is going to return those records. Let me run this. And these are the two records where it's both male and salary is more than 38,000. Similarly for R, either it's a male or salary is greater than 38,000. In all the records that you have here, either of these two conditions should be satisfied, right? So here it is a male, but salary is lesser than this much, right? So it is a male, so it is getting returned. So that's how the OR command works. Likewise, the NOT command, where not gender equal to male. So this will retrieve all the records where the gender is not equal to male, right? That would be female. So all gender is female here. Very, very straightforward, very direct, often used, right? Now you also have not in. So previously, when you used the not command, you had a very direct comparison. Whenever gender equal to male, you are going to not select those rows. Now here this is another case wherever gender is not in male. This is alternate way of doing the not using the not command. Could have written the previous way. The previous one we had written what? We had written Control C, Control V, where not gender equals to male. This is what we had written earlier, right? The same thing you can write it. You can write it this way also. Yeah. Okay. Combining and not or conditions. So you can combine multiple versions. The ones that you want to be evaluated before the other conditions, you need to put those things under bracket, right? So that first evaluate this particular or condition, then evaluate this age greater than 35 and the whole condition, whatever the result of that one is. Let's look at SQL min and max. This is also very, very direct. By the name it suggests, by the name of it, you can easily guess what it does. Minimum of a particular column will return the minimum value. Min of salary will return minimum, right? Likewise, max will return maximum value. Now, the thing is, you cannot use this min function inside a where statement. You can use it only inside the select statement. This has a great significance. We will try to understand it bit more later on when we look at more complex queries, right? I think in the next week's session only we'll be covering this in more detail. But remember this, whenever you are having a min statement, min, max, average, all these things, you can use them inside the select statement, not inside the where. So here previously you're having a where statement, right? So you cannot use age is greater than the minimum of age, right? You cannot do this. We cannot do this, right? So whenever you are using a minimum, you need to have it inside the select statement, minimum or maximum and things like that. So that makes sense. Now here we are using group by command, right? So we are grouping by gender and we are selecting the salary, right? If you are going to be grouping by gender, you're having the salary as a numeric column. You need to be aggregating the salary. Think about this. There are so many rows in your data that contains female and male values. If you're going to be grouping by gender, grouping by the female and male, if you're going to be doing that, it will try to summarize what is the value for each of the unique values present in this particular column, group by column. The unique values are female and male, right? The output will have all the data grouped by these two values of gender, female and male. And whatever column that you include along with this has to be aggregated. So if it is a numeric column, it has to be aggregated. It could be the minimum, it could be the maximum, it could be the average and things like that. Hope that makes sense, folks. So here, whenever you are using group by, you want to aggregate this is a continuous variable. This is a continuous variable. You want to aggregate this using either the min. Typically, people will use the minimum, maximum, and average. All right. Likewise, you can use the max also along with group by. Let's also look at the other different functions. The count. Previously, we looked at count star to get the number of rows, right? So that's where the count will come. Count returns the number of rows that satisfy the condition. Then the average sum group by index, right? We just saw an example of how to use group by. And we already saw group by right now. We have seen an example on group by. Let's see an example of this. So count returns the number of rows, average returns the average number of numeric column, average of a numeric column. Sum returns, adds together all the values in a numeric column, right? These are all group functions and cannot be used in a where clause. I've already covered this. I've already said this. Here we are saying it again. Now, here, what does this query do? So from sample DF, under the gender column, right? It's trying to group by gender. So if you look at sample DF, here, instead of group by calling it as gender, right? We are saying group by one. One means of the columns that we have selected here. There are 4 columns we have selected. Of these columns that we have selected, group by the very first entry in the selection. That's what the number here we have represents. So 1 means it represents the very first item in the selections, which is gender in this case. Right? Select gender. Then here we are counting the number of records under gender, the average of the salaries, and sum. Right? So the output should have a female, and then a male. Then for each of these values, you should have the count of the gender, average salary, and the sum of the values, sum of var1. These 3 items should be present in the output, right? That's what the output here also shows. Count of gender, average salary, and sum of var1. Let's now look at the like statement and the wildcard statement. The like statement and the wildcard statement. So these are all the different wildcards. The very, very, very most useful one amongst all of this is the percentage wildcard. All right. You don't need to by heart or remember each and every one of this in extreme detail. Like that's not required. The only 2 things that, or maybe 3 things. If at all you need to remember one item, one wildcard amongst all this, it is this percentage wildcard. The second most important is the star. It represents 0, 1 or multiple characters. Here also it represents 0, 1 or multiple characters. Both of them are actually the same, right? You also have an underscore character, underscore underscore a underscore underscore. So this will match. So this is used for matching. All these wildcards is used for it's in Python. You have something called regex, regular expressions, right? It is used for text matching, right? So this particular pattern, a dash dash underscore underscore a dash dash, right? Underscore underscore. So this one will match all the words, all the characters that has any value in the first and second places, has an A, capital A in the third place, and any two values after the A. All those text that matches this condition will be matched by this particular. So this is a pattern. This particular written thing that we have here is a pattern. This is one of the patterns. Let's see this with an example. Right? Say using like character from sample df, select all the rows where the name is like capital E, small m, percentage. So what this means is the name starts with the capital E, then follows with the small m, then can have one character or more than one character also. It can be anything. It can be anything at all in the English vocabulary, right? So the words like Emily, emblem, all these things will be satisfied by this. So any name, so Emily and Emma, both of these names, the name starts with EM, capital E and small, followed by a small m. Only these two rows are satisfied, and that's why these two rows got picked up here. Find all the names ending with ON, right? To do this, so it starts with anything. It can have any number of characters behind it, before it, right? But ends with ON, and then it closes with a double quotes, right? So this pattern can have any number of characters initially, but in the end it should have O and N. So all these names, if you look at the output, Johnson, Wilson, Thompson, Anderson, all these names has ON at the end, right? That's what this particular wildcard does. So here, this part here, this is a pattern, right? And this item here in this pattern is a wildcard. This is called a wildcard. Okay. Find all names with Tom in the name, right? So have a percentage before and after. The Tom, so before means if it starts with Tom, that's also fine. It will fill, right? If it has some characters before and has the words Tom and has some characters after also, this will also satisfy. Both of these will satisfy. All right. So a word of caution and advice: don't try to master the like pattern whenever this is a situation that you're going to be facing now and then, every time to time. Even if I have tried to memorize it, it doesn't really matter. I tend to forget it. The only thing that I remember, typically the only thing that I remember is the percentage, the star, right? And question mark will be like one or more characters. I think 0 or 1 character, I think. The question mark here represents 0 or 1. I think it represents a single character. Even I don't know. Like this one, really, I don't know. So whenever you want to look up a particular pattern that needs to be written, right? You might have to Google some examples, how to match this particular, say it could be an email address, it could be an ID or something like that. How to match that particular situation? You do a Google and you will get an answer to that. Typically, right? From that answer, you might be able to tailor the pattern for your specific need. It only works on strings. That's correct, Salman. Yes. It's meant for strings. Next one, we will see the in and the between operators. In and between. So it's also, both of them are used with the where condition. So name in, whatever value that you are passing here, if name contains any of these three values completely, right? If the name value of name in any of the cell contains Emily Johnson completely or Eva Martinez completely, like that, all those will be selected, right? Only these three folks are getting selected here, right? Or the same thing, you can write it as name equal to this much, or name equal to this, or name equal to this. That way also both of them are equivalent. Right? Simply here, this is more elegant. This is what I prefer normally. Okay. SQL between, so salary, so where, this is also a where condition. SQL between operator is also a where clause or where condition operator. So salary is between these two values. very conveniently written, right? So between these two values, you can use that and get the answers, get the outputs. Okay, so we'll move on from this. So there's also not between. So you previously we had, or it will return. So if you did not have the not here, it will return all the values between these two cells. Having a not here will return all the values, all the cells whose values lie outside this range, right? That's what the not between achieves. Exists. This is interesting. Please pay attention to this. This is quite interesting and quite useful also. This is useful because it achieves, it can be used to achieve some of the same things that we achieve using the different types of joins. We saw the 4 different types of joins in the previous class. Remember, we have the inner join, outer join, left join, and right join. 4 different types of joins we saw in the previous class, right? Now, SQL Exists here can be used in place of joins. In place of joins, as an alternative to join, you can use Exist. This is more faster in nature. Generally, is much more faster. There's a reason to it, right? That is not so. There's different purpose to the reason of different purpose to exist and join. Right? Join is used for joining the 2 different data sets. Whereas exist is just to check for the existence of a particular cell or particular condition or values, right? That's what exist is meant for. But by use case, it can be used in place of joins also. Let's understand that as an example, right? Let's create a table here. So we have a customers table. We have we have customers. Under customers, we have the customer ID and the customer name. Just two columns we have, and we have inserted 4 different values inside that table. Now, let me run this. We run this so that we have this table. So this is run now. Now create an orders table also. So if this has order ID, customer ID, and order date. So 2 tables created. One customer ID and customer name. Then order ID, customer ID, and order date. Customer ID is common between both. All right. Now this is customers and this is orders table. Now the task is how to select the customer names from the customer table that are present in the orders table. So here, look at this. Look at this. In customers, there are 4 different customers, right? First 4 different customer ID, 1, 2, 3, and 4. We want to select those customers or customer IDs that are present in the order table. That means we want to select customers, those customers who have placed an order. Right? We want to select those customers who have placed an order. To do that, we will look up this one. So the customers who have placed an order are customer 1, 2, and 4. Customer 3 did not place an order. Right? So by looking at the table, we know this. But imagine these are 2 very large tables. Manually doing it will not be possible. It's not feasible. So how to do this? So the task is from customers table, select the customer names that are present in the order table. The customers who have placed orders, right? So imagine if you did not have the exist statement, how would you do this? So you have the customer table, right? You will do what we will do. We will do a select. We'll write the select what comes here. So select necessary columns from customer. So from customer, anything that is present in orders, you will select, right? So from customers, customer, we'll call this as A. Then left join, we will do a left join it with the orders data. Orders, we will call it as B. On A dot customer ID equals to B dot customer ID. Right? So we have joined this. So to this table, we are joining. We need the order ID, right? Order ID. Right? Say we are taking, so from here, the A dot customer name we will take, right? From B, we will take B dot order ID. We will select these 2 columns, right? Customer ID also we have selected here, say a dot cust ID. So this is present, customer name is present, order ID we have taken. ID, name, and order ID. Customer ID, customer name, and order ID. We have taken all these three, right? And values will be filled here. Now, if this is so we are joining by customer ID, right? We are joining by customer ID. So this customer ID is present in order ID. We know that this alone, the third customer alone, has not placed an order. So this cell alone will be missing here. This cell alone will be missing here, right? So after joining this, we can do a where condition. We can do a where condition where order ID is not null. That should, so this entire query should solve the problem for us. Making sense? Does this query make sense, folks? Is this clear? Would this solve the problem? Right? Now, since the task here explicitly in the task, we have said select customer names. Let me erase this. In the task, we have explicitly, it has explicitly asked to select the customer names. So in the output, we will not include customer ID and order ID. Right? Only the customer name we will select and give in the output. So these would be the customer names that has orders. Is this query making sense, folks? If it is clear, please type clear on the chat so that I will know that you're following along. Thanks for confirming that. Anyone else facing problem? I think it's not clear, folks. Great. I don't see anyone having a trouble understanding this. Okay. Now this is created. Now you know how to implement this. Using joins. Using a left join specifically in this case. How to implement this? This is clear. Now let's do this. You can do the same thing using exists function. Okay, using exists function. Typically, exists is faster or more efficient than joins. All right. Simply here in this case, we simply want to check the existence. So from customer, select customer name from customers. Select customer name from customers. Where exists, there's no joining happen. Where exists, use the exists command. Select order ID from orders where customer ID, customers.customer ID equal to orders.order ID. So all the rows where this condition, all the rows from orders that satisfies this condition, right? Customer ID dot order ID. So where all the rows from order that satisfy this condition will have the value true. So so you're selecting from customers, right? So from customers. So how this works, let me explain. So from customer table, you have the ID column, customer ID. I'm writing it as simply as ID, and you have the name column. Both of these columns are you have, right? Say this customer ID 1, 2, 3, 4, so on and so forth. So you have these IDs. Now from this, you're selecting the name column alone. The name column alone you are selecting here from this, and whether to and inside this column, it will iterate through every other cell. Every other cell it will try to iterate, right? It will go whether to include this or not. We have a where condition, right? That's how where condition works. It will check if this condition, this cell satisfies or not, this cell satisfies or not, right? If it is true for this cell, then it will return answer is true. Now here, see this under exists, where exists, it is doing from orders table if this order ID is present or not for this particular customer name, or here in this case we are joining with the customer ID for this cell. If this condition, if this statement was holding true or not, that's what this one should return out, right? So here it is trying to join the order ID of this order ID that is present inside customers equals to orders.customer ID. If that order is present inside the the orders table, if this customer ID If this customer ID inside orders also, you have a customer ID column, right? If this is present inside this column, this is orders table. This is orders table. This is customer ID, customers table, right? If this is present inside any of this, inside any of these cells, then it will read. Suppose if it is present here, then this will be returned. Order ID, okay. Order ID is this one. This is customer ID. This is order ID. This is customer ID. This is order ID. So if this is present, this ID is present, then this will be returned. Since this is returning a value, right? Then it exists. Simply exists. That's what it means. Right? Likewise, it will do the same check for this cell, then this cell, then this cell, and then this cell. Right? The ID corresponding to this cell, if it is present inside the CID, customer ID of the orders table, right? Then order ID will be returned. Then the order ID will be returned. And since this is returning, it exists. So this condition satisfies for that particular cell of customer table. Hope this makes sense, folks. Hope this is clear. Please let me see if there are any specific questions. This is not a subquery. This is not a subquery yet. We are not talking about this. Is still okay. Subquery is a completely different. It's not a complete. It's a related concept, very much similar to subquery. Here we are checking a condition here. You can think of it as a subquery. No. It's not a really strict problem here. Think of it as a subquery. So here where exists, it's basically a condition. Where exists for every other cell, if it is true or not. If it is true, then good. Then it will include it. It is very much similar to VLOOKUP. Exactly. Does it work like a, no, it does not work like a left join, because a left join will try to join the entire data to the other data set. You're trying to join two different data sets entirely. Right? It does not stop. So the difference between left join, a join, and an exist, right? Once an existence has been found, this will stop and yield a true. Right? Once it has found the existence, it will stop at that point. Whereas the join, right, it will continue to do the process even if it is found true. So because it is coming out after an existence has been confirmed, this is much more faster than doing a join. Right? The other difference with join here is, here we are not, so even though we are referencing that orders table here, select orders from order ID, right? We are referencing here, but we cannot have any of the fields from order in the select command. So we cannot have an order ID here because no joining is happening here. You can have only the fields from the customers table in the select statement. That's another difference between the exist and join. And that's actually the next part of this we are trying to cover. So whenever you can achieve the same result, it's a bit more faster. Generally, the exist is, if you are able to do it with exist, it's generally a bit more faster, and you cannot select a column from a second table. That's the main difference. Let's move on. So SQL aliases is very straightforward again. So here we are doing a join. We are calling the customers as A, right, and orders as B. These are aliases within the scope of this query alone. When you come out of the this query, the value A and B that we have defined as aliases inside this query does not exist anymore. Right? So that's what an aliases are. It's easy to write your query using this. Also, you can also write it as you can use an alias here as CID. Something like this is also an alias, but this will be the name of the column that we will be using to store in the database, store in the table. Next is case statements. Case statements, so you have a numeric variable. You want to convert it into a categorical variable based on various categorical variable based on various rules. You can use case statements for that. Right? Alternately, you can check multiple conditions, one case after the another case after another case, like that. You can have multiple cases, do multiple, like if you can think of it as if else, multiple levels of elif statements is there, right? Elif statements. So you can think of it in multiple levels of if-else statements as the case statement in SQL. Let's see an example. Here, if salary, so you have this whole statement, this entire statement is just one single case statement. Whole statement here is just one single case statement. There is no comma here anywhere in between. Notice that. This is a very, very common mistake that beginners used to make. No comma here. Right? So if salary is greater than or equal to this much, then it's a manager. Salary is greater than or equal to this much, then it's and salary is lesser than this much, then senior analyst. Otherwise, it's an analyst. So you have a case, then write your conditions, end it, case ended with an end, and as the name of the column that you want to store it as. Next one is SQL operators. There are multiple arithmetic comparison operators. Let's just formally define it. These are the different arithmetic operators. The plus, minus, star is multiplication, slash is division, percentage is the modulus, which simply returns the remainder part. Remainder part of any division is the percentage sign. All right. And for comparison, you have the equal to, less than, greater than is nothing but not equal to, or the exclamation mark followed by an equal to sign. Both of these are equivalent for not equal to. Greater than, less than, greater than or equal to, less than or equal to. All these are the comparison operators. Likewise, you have a logical operators and not, we have already seen these operators. And we are just formally defining the different operators that exist in SQL. Now it's time for the next assessment set. We'll try to solve this. The remaining questions, the remaining part that comes after this assessment is quite straightforward. All right. I'm going to, so will first define the exercise questions first. Then I will paste the question itself onto the chat, or you can, if you're watching this as a recorded video, you can refer to this in the q2.sql file in the resources folder. You will have access to that. You can take q2.sql. You will have the query that is used to create the title table, sales table, both of these two tables. You can create it and solve all these questions on both of those tables. Now, the first question is find the minimum, average, and maximum of the titles, maximum price of the titles. The output should be looking like this. All right. Second question is retrieve the title where the price is between 10 and 15. What is the average YTD sales of all the psychology titles? Retrieve all the titles from title table that is also present in the sales data using the exist command as well as the join command. All right. There can be multiple ways to do that. In many other ways can be possible. If you have, please do share that in the comments area. Okay. Let's get to solving this. Now, I'm going to answer the first question, which is get the minimum, maximum, and the average price. Min of price is minimum price, max of price is maximum price, like that. So instead of doing it in the fiddle, I'm just going to write it here itself. It's more convenient. So I'm running this code, then select star from title gives the values, then select star from sales, we have the values. Then to get the minimum, maximum, and average, run this query and you should get the answers. I'm going to copy this and paste it in the DB fiddle. And it should return the answers without trouble in DB fiddle also. All right, so here you have the answer, minimum, maximum, the average price answers. Good, so that's fine. Second question is solution for Q2 and Q3. So select title, retrieve the titles where the price is between 10 and 15. Right, title price where price is between 10 and 15. Run this and you have it. Right, all these are all the different titles. What is the average year-to-date day sales for all psychology titles? So again here, put a where condition and put type equal to type psychology and compute the average. So this should be the solution for the second or the third problem. Fourth problem is retrieve all the titles from title that is also present in the sales using the exist command and then using the join command. In general, say this is another very good roundup of the difference between exist and join. You don't need to return, you can use exist when you don't need to return data from the related table. Right? And if you have dupes in the related you will use exists if you have duplicate values in the related table. All right. And you just want to check the existence, you want to use the exist command. Okay. Now using exist, this is the answer. So select title and price where from title where exist you have the from title, this title should have some data point existing in the sales column, sales title ID. Right, select star. This does not matter. What value you have here does not matter. Right, from sales you have the title ID. So what's the question here? Retrieve all the titles from title that's also present in the sales. Here we have one more condition added. The quantity is more than 15. This is not needed actually. Okay, so that will add one more condition on top of this. So select all the titles and price when say title ID sales.title ID equals to title.title ID. If it is present inside sales, then it will return the results. All right, so these three items. If you want to add one more condition where say return only the titles where and what was the condition? I think the price, right? Price is more than 15. Price is more than 15. Then it will return only those records where the price is more than 15 value. That was the previous query. You can do the same thing using join. Join title with sales on title ID on both of these tables where quantity. Okay, here is quantity. Here it's price. Here it's quantity. You can say s dot price here as well. No such column called s dot price. In sales, what is it called? In sales, there is no price, there's only quantity. So where is price? Price is present inside title. So I should refer to title. I should refer to the title table where t dot price is greater than 15. All right, so it's returning duplicates here. This did not happen in the previous query, right? If it is present, then it is giving out the value. Otherwise, it's not giving out. The next one is string operations. Under string operations, one of the very common string operations, concatenating multiple strings from multiple columns or multiple text, multiple strings to form one single column. So here, select star from sample df gives us this output, right? Select star from sample df gives us this. Now, you want to create a new column named name and gender. We want to concatenate name with gender and name the column as name gender. You can use the double pipe. Double pipe is the concatenation operator. Here, name, concatenate with the space character, then concatenate again with the gender column. That gives the output, and you have this here. This is absolutely meaningless, name and gender, to have it in one single column. This is just purely for demonstration purpose. You can do an exercise. You can take this as a homework where say you have from sample df. So if you are running this on a Jupyter notebook only, you will be able to solve this. From sample df, right? Create an ID column that concatenates the current ID column, the salary and the age, which are joined using the underscore character. So if the current ID is this, salary is this, age is this, the output should be current ID underscore salary underscore the age. That's the ID, and we are calling it as current ID. And this is the solution. Like I'm probably you would have got this easily, so it's not that. Okay, let's move on. So we have a harder question here. This is a harder question. We'll try to solve this. If you are getting this, then you have a very solid understanding of all the concepts that we have seen, all the tough concepts that we have seen so far. The two main tough concepts that we have seen so far, by the way, is the group by, the exist, and the joins. These are probably the three main tough concepts we have seen so far, right? Now, here the question is, how do you retain those records where the price is either? So from the title table, I should explicitly write it as, how do you retain those records from title table where the price is either the minimum price or the maximum price or more than the average price. All right. But I want the entire row to be returned out. here, if you look at it, you have the title, you have the price, you have the, in addition to this, you also have the minimum price getting printed out for all the rows, maximum price printed out for all the rows, and average price getting printed out for all the rows, right? This kind of an output I want. I'm printing out for all the rows because I can compare for every row, right? I can compare whether this is minimum price or not, or greater than, or is greater than the average price or not. I can do this comparison. Let's solve this. This is a bit more. Once I solve this, you will get to understand. If you already solved this, great attempt. I don't expect you to solve it in the very first attempt. It's perfectly fine, right? It involves a bit of understanding and practice in order to be able to solve this. We will come to this particular exact or very similar and exact question in the next class also. All right, next class will be even more rigorous than what we are seeing now. Next one, we will be taking in steps. Nothing will seem overwhelming. We will go there in steps, but we'll be covering a lot more very tougher concepts. We will study it in much more detail, right? Now let's try to understand how to make this work. Now let's try first step. Here we want to compute the minimum, maximum, and an average price, right? So we want to select all the titles whose price is either minimum or maximum or average. So in order to do that comparison in the first place, you need the minimum, maximum, and the average first, right? So let's write that query. So select title, price, then minimum, maximum, and average. If you run this, you'll get just one single row. You'll get the price. So this does not matter. It has computed the minimum price, maximum price, average price. Then the very first record it has given out. The very first record is secret 20. Because it is coming out as the first record, that is the reason it has come out as the very first, come out in this particular output. Okay. Now in this one, what we want. So these are the output columns. We want the minimum, average, and maximum to appear as rows along with the titles. So here, if you select the title and price, so you select the title and price on the title table. Once you select it, we want to. So this is the title. These are the two columns of title and price. So this is the entire table. From this table, I'm retaining only the two columns, title and price. To this, I'm attaching. I want to have the minimum, maximum, and average values to be printed out across the table, entire table, right? That's what we want to have. So to do that, right? So we merge the main table. So we want this to appear in all the rows. Then we merge the main table and filter out the rows that satisfy this condition. But based on what column to join, we don't have. So we have computed this. We cannot. How do you join this to the title table? So here you have the, let's say from the title table you have the title and price, right? You also have computed the minimum, maximum, and average price, right? We want to join this with this table. We want to join this. This is the minimum, maximum, and average, right? We have this data computed, but based on what value to join this? Based on what column to join this? So we have this, and we have this, and we have this. We want to join both of them. But to do the join, there's an on condition, right? Let's call this A, let's call this B. A dot sum column equals to B dot sum column. Then only we can join both of these columns, right? Isn't it? So think about this. How would you do that? How would you do that? So here, this is the output actually. This is the final result. So here you're selecting the all the fields that you want. Ignore this part for now. Okay. So we are joining title. We are calling it as A. Left outer join. So title table. We have the title and price. We are calling this as A. Right. To this, we are joining select title, min price, max price, average price. Select select, we have one title here. This is the first occurrence. I think the select title name was something. I'm not sure. Okay. Then we have the min, max. This does not matter, by the way. This does not matter, I'll tell you. So an average. To this is B. We want to join A and B. The on condition, if you put it right, on title, A dot title equal to B dot title. So here, I think the title was, what was the title? Secrets. So if you look at the titles table, you have where is that table? Secrets, let me erase this part. You have secrets, the emotional, prolonged, and all. So secrets, the emotional, prolonged, and so on. Here, the value here, it took the first value alone, right? So this is secrets. Now, if you apply this query, here, what would happen? If you run this query, right, it will try to join this, then these two cells, these two tables, based on the title here, A dot title equal to B dot title. So the output would be, let me write it in different color, min, max, and average, three columns, right? Out of this, only secrets will be filled. So this is all the present. This is all present. Now out of this, only secret is present here. So this values will be present, but these will not be present. These not present, emotional not present, prolonged not present, all the other values is not present in this table, B table. So all the other values is going to be missing. Getting me? So how do we solve this? Pay attention to this. How do we solve this? Is we need to make sure the condition that we have here, we have here has to hold true, not just for the first column, but for all the columns that we have in the data. For all the columns, we need to make sure this condition holds true. How do we do that? You can do a simple comparison, say you can do a dummy. You can do the value 1 equals to 1, or 2 equals to 2, or 3 equals to 3, something, or character A equal to character A. This statement is going to hold true for all the rows of this data, right? But this statement, A dot title equal to B dot title, will be holding true only for the first row. But if you write it as 1 is equal to 1, no one is restricting you to make a comparison here, 1 equal to 1 comparison, right? If you do this comparison, it will hold true for all the rows in the data, and that will make sure you are getting a value for all the rows here. Hope this makes sense, folks. So let's see the output here. So on running this, you see only for secrets row, this data is present. All the others is not present. Right? For all the other rows, it is not present. Whereas we change the on condition, we change it to 1 equal to 1. Only this we are changing here. On doing this, you have that condition be satisfied for all the rows. You have these values all coming out, right? All these are filled out. Then finally, you can apply a where condition. So select star from, so I'm storing this entire table. This entire table is stored in a new table called temp. Create table temp as, store all these results into temp table. So select star from temp, where price equal to either min price or max price or greater than the average price. That will give you the final result that we are asking for. Is this clear, folks? This is key actually. What we just discussed is actually key. You might want to go back to the recordings and see this one more time to really drive this to your bones. Hope this makes sense. Is this clear, folks, how the join condition works and how we solve this problem? All right. Then we have a substring function, SUB-str function that can be used to extract a specific portion of text, portion of characters from a string. Right. That's why it's called a substring function. Pass the name of the string itself. It can be a column name. Mention the starting position and the length of the string. That will give you then the text that you want to, the characters that you want to extract from that string. So select sub-str from name. Select the characters in first, second, third, and fourth and fifth position, first 5 positions. So it should be typically of length 5 or lesser. Now, how to separate the first name and the last name? Say, suppose you have a full name, right? You have the name from that. So my name is Selva Prabhakaran. You want the Selva in first name and Prabhakaran in last name, and two different separate columns. You can still use sub-str, but you need to know the position where the separation happens, the position of the space character, right? That position can be returned using the instr command. The instr will give you what is the position where this particular character occurs for the very first time, right? Using instr, you know what is going to be the length of the string. The position -1 is going to be the length of the string. Pass this here, then that will become the first name. Then for the next last name, right? For the next last name, that will be the starting point. The instr command's output will be the starting point, right? Okay, so here, and if you don't give a third character, right? So length of the string is not given, means the remaining part of the entire string will be taken as output. So that's what is happening here using this command. We have a length or len command is also very useful for string operations. Depending on what database you are using, it's typically going to be the length or len. It will give you number of characters present in a given string. That's all. In SQLite, this command is length. I think in MySQL, I'm not sure, you might want to check this out. This, instead of length, you might want to use len. Or it could be length also. I'm not completely sure. It get mixed up between length and len. All right, so here you have the name length as another new column being created. You have the upper and lower functions. Any word written in uppercase, you want to convert it into a lowercase, you can use a lower function, and lower to upper, you can convert it using the upper function. So this is the output of using the lower on any given text column, and you get the output. Likewise, you can use the upper column, upper command to convert all the names to a capital case, all the characters to capital case. Then trimming text, you can do it using the trim function. Pass the text itself to trim. It will remove all the space characters before and after the text. You can also remove some unwanted text also. So here XX is present initially, right? So to trim, you can pass the character that you want to trim as the second argument. You can do a left trim alone using ltrim. If you use left trim, all these space characters before the string will be removed, right? And you can pass an additional parameter to ltrim. Any other characters besides space you want to remove, you can pass that as a second parameter. Likewise, the same conditions and logic applies for rtrim, which stands for right side trim, right? Then you have multiple characters also as part of the second argument for trim. This is also a similar example. All right. Now here in this case, I am having an O here. This has to, so whatever that you want to remove from before or after the string, after the string, that has to be continuous. So I have a O here. It does not mean that it will remove all the O's present inside. That if O is present here, only if ABC and O is present continuously before or after the string, only then it will be removed. Then replacing the occurrences. So in gender, we are removing all the males, replacing all the males with M and all the females with F. You can simply use the replace command. Now we have a self-assessment exercise. These are the questions for the self-assessment exercise. I'm going to write this up. I'm going to read this out. You can pause, try this out on your own, either in db-fiddle.com or in your Jupyter notebook. Or if you are able to make your MySQL Workbench work, then you can try it in MySQL Workbench. So here, these are the questions. Filter all the records where the name has exactly 5 characters. So all these exercises are based on this particular table that we are creating here, the customer table. All right. So these are all string related text-based exercises. Filter all the records where the last name has exactly 5 characters. Second question, create a new field called full name with MS as salutation. For example, the first name is Mary and the last name is Smith. The full name should be Miss.ms.Mary Smith. Then extract only the username part of the email. For example, email equal to mary.smith@sakilacustomer.org. The username should be the very first part, mary.smith in small case. That should be the username. Right. Finally, find what is the average age of customers of store IDs 1 and 2. In separately, what is the average age of customers of store ID 1? Likewise, what is the average age of customers of store ID 2? These two cases are separate cases. Use this as the input table. We had used this in the previous lessons also. This is a part of the Sakila database that comes by default with the MySQL. Whenever you're installing MySQL Workbench, you will get this Sakila database as default. Use this database to solve all these problems. So here are solutions. First question, filter all the records where the last name has 5 characters. Okay, so select star from customers, all the columns from customer where length of last name equal to 5. So this should give you the required answer. Then what is the average age of those customers? Right. So then instead of select star, you need to do, I'm not sure if we have the answer here. We have it. So average of age where length of last name equal to 5 and age is not null. Right. That should give you the answer. Let's solve the second one. Create a new field full name with MS as salutation. Right. So first name, last name you have, then MS, then concatenate the first name, then concatenate the space character, then concatenate the last name and call it as a full name. This should give you the output. Look at the output. We have the first name, last name, followed by the full name, and the full name looks good. Let's now solve the third question. So extract only the username part. So here, this is a tricky one. You need to find out the position where you want to extract from this entire string, right? So we know we want to start from the first character. We are using substr email. From the email, we start from the first character and we find the position of the @ symbol in this entire email, right? That you can get it using the instr -1. So @ symbol -1, right? This is where you want to stop till h, right? And put it in lowercase, and that will be the username. So there you have the answers. Finally, what is the average age of customers for store IDs 1 and 2? So for store ID 1, select average age as average age 1 from customer table, where store ID equal to 1. Very straightforward. Nothing to think about here. You should answer this immediately. Likewise, for second store ID put inside the where condition, put store ID equal to 2. All right, so that completes all the different topics that we wanted to cover in today's class, folks. Now, the very first concept is subqueries in SQL. What are subqueries? When someone writes a query, right? Typically, queries look something like this. Say this is a create statement. We are creating a table called employees. Let me run this. This employees table contains 4 fields: the ID, name, salary, and department ID. 4 different columns we are describing here and putting some data into it. Likewise, we are creating a departments table which contains ID of the department and the name. The department ID. Earlier, we had the employee ID. This ID corresponds to employee ID. Here, we are having department ID. All right, one more table we are creating. So we have created 2 tables. One employees table that contains 4 different columns: ID, name, salary, and department ID. All right. Second, we have departments table which contains ID and name. All right, 2 tables created. We will create just one more table, which is the sales table. It contains the employee ID, product, and quantity. No need to memorize any of these things. No need to remember. We will be doing this over and over again. You will get comfortable. Okay, don't try to memorize anything at all in the first place. Generally, right? This is general advice. Never try to memorize anything. Okay, so we have created 3 tables. Let's print out the contents. To print it out, we have select star from employees. These are the contents of employees table. Likewise, for departments, we have 2 columns, just 3 entries. And we have sales table, which has 3 columns and these many entries, all the rows of sales table. All right. What it means is the employee ID 1 sold product A of this much quantity. That's what the sales table tells us. Now, let's understand subqueries with an example. If you solve examples, it makes the understanding a lot more easier. This is example. So let's understand this with an example, right? Find out the employees who earn more than the average salary. So here in the table, go back to this table. We have the employee IDs. We have the employee IDs here. We have the salaries of these employees over here. So we are concerned with this particular table because this contains the salary data. Now we want to know who are the employees who earn the employees whose salary is greater than the average salary, whose salaries are greater than the average salary that all the employees earn. That is the first question. All right, simple. In order to solve this, very simple way to understand why we need to have queries in the first place, right? Why we need to have subqueries in the first place. We will try to understand with a very simple example. Okay, in order to write this query, how you will write it? We have here, let me make this zoom in a bit. Okay, this is, I think this is a very large legible size. This should be comfortable. Okay, so look at this query. We want the name, we want the employee name, and we want the salaries of those employees. We want the salary to be greater than the average salary across all the employees. This is what we want to get, right? So we are getting the name, we want the salary from employees table where salary is greater than the average salary. All right, but if you try to run this, query, it is sort of erroring out. This is giving an error. What it says, misuse of the aggregate function AVG. We are doing an aggregation here. AVG of salary should compute the average salary. But if you're going to be using it under a where clause, this is not permitted in SQL. Right? If you want to compute the average, you cannot simply write average of salary, because you can use this average of salary only inside a select statement. You can do something like select average of, you can do select, first select name, employee name, then salary, then you can do a select average of salary. This will work. Then from the table name, right? If you do this should work. Let's try it out. In fact, let's try it out. Control A, Control C. Let me open up a new cell here. Instead of doing this, I can write AVG of salary. If I run this, I can remove the where clause entirely. Okay, so if we run this, what we see here is we are getting the average salary, but that is only one entry here. It's giving us only one entry because this is a one single number. This is getting returned, right? But here we want to select, here is giving, since Alice is the very first entry, it is just printing out the first entry because we have the name and the salary printed out over here. It will just print the name and the salary for the very first entry in the data table, right? But this is not what we want. We want all the names of all the employees whose salary is greater than the average salary. If we have something like this, say the second name, so second employee comes, third employee comes, all these employees are there, and their salaries are there, and the average salary is also getting printed out, right? Once you have this kind of a table, you can simply do a where clause, where salary is greater than average salary. All right. Later on in today's class, we will see how to create this kind of a view also. All right. We will see this, how to do it during when we are looking at window functions. But now try to understand. What you need to understand is you cannot use this kind of average or min or this kind of aggregation function. When you can do this, because doing an average, right, it will give you only one record. Right. First of all, we cannot use this inside a where clause. So in order for us to make this work, how will you do this? We can do it first. We can create a new table. Alternate approaches. We can create a new table called average salary. In that table, we can store the average salary of the employees. Let me run this. Let's run this. This has been run, and let's print out the contents of average salary. It's showing 52,000. This is the average salary of all the employees. Okay. Now, if you write a query around this, you can say the salary, the same query, select the name and salary from employees where salary is greater than the select average. Instead of earlier, we had average of salary, right? Instead of doing this, we are writing the query itself. We are querying from another table, getting the value of average salary from AVG salary table and doing this comparison from this one. Getting me? So this is the part. So here we are able to insert another query inside the main query. All right. So you can think of this as the subquery. We also call it as nested query. Hope this makes sense, folks, how this works. I'll be recapping it soon, shortly, Salman. Fazul, your question, please, I have answered these questions, folks, about previous classes. You can access the last 2 classes also. Usually we give the access for just 1 week. Since we are still talking about SQL and there are new learners, we are giving the access till the end of next week. Okay. Don't see the full name. Kama has asked, what is the advantage of using a new table for average sal? Can we store it in a variable? I'll come to that. I haven't completed the explanation, Kama. We'll see that. I'll do a recap shortly. Yeah. So we have essentially stored the average salary here in average salary table. All right. And from that table, we are getting the average salary field. There's only one field, one entry in this entire table. That is this one, average underscore salary. To see the table, here it is, right? So we created average salary table. It contains one column and only one entry in that column. We are getting that inside this query and making the comparison. Okay. Now, you might think, okay, we are creating another new table. We are creating an altogether entirely new table. Just one single value is stored. Can't we somehow calculate this value without creating a new table? Is that even possible? Yes, it is possible. So instead of creating this entire table, right, we know all this data, this information of computing the average salary can be computed directly from the employees table. Correct? So from this table, employees table, we can compute, instead of referring to the newly created table, we can simply compute select average of salary from employees directly. Instead of doing average salary, we earlier did select average salary from the new table, right? AVG salary. Instead of doing this, we are computing the average salary from the employees table itself. So this table, in this query, we are referencing this table 2 times. Employees comes here and employees comes here. All right. Remember what we did. So let's do a quick recap. All right. Let's do a quick recap. This is a foundational understanding of what you need to know about writing subqueries. Why the subquery is needed in the first place. If at all it was possible, we could have simply written this query like this. Let's do a quick recap. Instead of what we want the names of the employees. We want the names of the employees whose salary was greater than the average salary. This much we know, right? Doing a quick recap so that you don't miss following along for the rest of the class. So we have the employee names, the employees, and only those employees whose salary is greater than the average salary. Right? We want only those records. We could have done this if SQL allows, right? We could have simply done this. If it was Python, you would have. If you are a Python programmer, you would think like this, where salary is greater than the average of the salary. But you cannot write this in SQL. Whenever you are computing the average, it has to go along with the select statement. Same applies for min, max, all these commands also. Yes, aggregation commands basically. Now this is not possible. In order for this to work, instead of saying average salary, you need to put a query here. You can put select AVG of salary from the salaries table. So okay, this is not salary, this is employees table. From employees. Okay, this is the whole funda. This is the whole idea behind writing salaries. Let me see if there are specific questions. If we wanted the average field, we could add to the list on the outside query. Lost the target. Not following the question, Furman. Yes. We could add to the list on the outside query. If we wanted the average field, we could have added to the list on the outside query. Not sure what I'm getting here, Furman. My apologies. If you could explain it better, it will be great. Why is the alias E1 required? Good question. It is not required. This is just this is optional, completely optional. This is not required, Robert. Hope that makes sense. Okay, so by now you should be clear what is the need of subqueries in SQL in the first place. What is the limitation? We cannot do this. The answer is this. We cannot do this in SQL, right? For that purpose, we have to go for and write subqueries. By now, by the end of this, you need to understand. The only thing that you need to understand is when we need to go for subqueries. Why is subqueries even needed in SQL? And an example of how to write a simple subquery. Let's take it up a notch a bit. Let's try to understand subqueries a little bit more with a slightly tougher example. The next example we are going to look at is find out the employees who earn more or equal to the average salary in their respective department. All right. So previously we wanted to find employees whose salaries was greater than the average salary for the entire company. Right? Now this time we want to do this comparison within their department, within their respective department, who are the employees who earn more than their average salary. Can you think about how you would even solve this? How would you even start writing this query? I have mentioned the approach that we are going to take. We are going to do this without using a subquery first, and then put in the subquery after that. Okay, let's see the answer. Think about how you would solve this. Now let's see the answer. All right. Okay. Now what we can do. So what data we need? We need the names of the employees. We need the salary. All right. We also need the average salary within the department. So alternately, we also can, let me write it over here. Let me write it name of the employee, which department the employee belongs to, the salary of the employee, right? The average salary within the department. Once we have this data, simply we need to see if the salary is greater than this average salary within the department. If that is the case, we will retain that record. If it is not the case, we will remove those records. We will not retain those records. That's the whole idea, right? This is what we want to get. Now to create this, right, we have the name department, we have the name of the employee and the salary in one table, right? We have the department ID also is present. Now what we need is for every department, we need the average salary of that department, right? We need the average salary of that department. Once you have this, we will merge it with So in the original data, not this one, we will merge it with another table where we have the employee name, their salary, and their department ID. This is also ID, right? We will join this with this table and get this table. Getting the flow? So first, we will compute this table. This contains the employee salary and the department. Second table, we will have the department ID and the average salary. We will merge both of them together and create this table, which contains all the information we will need. Once we have all this information, we will be able to select the records where the salary is greater than the average salary within the department. Right? This is a logical way of solving this. Correct? This is a very, very, very logical way of solving this. Now, let's do this. First, we will solve this using this approach. Then we will see where to put in the subquery. Okay. You will get good at writing subqueries. To get good at writing subqueries, you start writing it as if you are creating a separate tables overall. Right. Once you solve that, then you replace those places where you are creating a separate table with a subquery, so that the new separate table does not get created. Like we will see how to fix it, and so that you will understand where it comes. Okay, so here we have the employees table. This contains the name, salary, department ID, all the information. This is our table 1. Next, we will compute the average salaries within the department. So we are creating a department salary table. Here we are getting the department ID and the average salary of that department grouped by the department ID. All right. This is also coming from employees table, because employees table here contains the department ID, contains the salary also. So to get the average salary of department 1, we will just take an average of this value and this value, like that. Simple. Okay. So from this, we are creating another table which contains the department ID and salary. So both the tables that we need have been computed. We are going to merge this table, the department ID table, to the salary table, or sorry, the employee table. Okay, by doing this, we should get another column, the average salary appended. So this is average salary within the department. Hope this is clear, folks. Now, how are we doing this? We are join. So to read a query with the join, right? How you can read it? Start reading from the from statement. From employees. Okay, we're calling it as A. Left join department salary. We have computed this. Call it as B. So you're joining A and B on the common column, which is department ID on both of these tables. On department ID. So the tables have been joined. Right. So now the two joining has the results of the employees table. The employees table, to that the B table, right, has been added, department table, which contains the department salary information are again added. The common column is department ID, which is the common column. All right. So we have all this information. So this is A, this is B. From A, we are taking everything. All this information is taken from A. Right. From B, we are taking the average salary. Right. Average salary is just one column is present here. So the entire table is put up over here. This is what is happening. Correct. So from this, we want those records where the salary is greater than the department average. So does this satisfy the condition? No. This is also not satisfying. This is yes, this is equal. Right. This is also satisfying. This is also satisfying. So these 3 records should be returned. We're finally adding, after joining it, we're finally adding a where condition where the salary is greater than the average salary. And these are the records. Carol, David, and Ethan. The last 3 rows. Yes, these three rows have been returned here. This is a step-by-step logic of doing this using a regular approach by creating a separate table, joining it, and then doing our operations. Now, where can we put in subqueries? In this entire thing here, in this query, right? This is the entire query here. Okay. Here we are doing a left join on department salary. We are doing a left join on department salary. right? Can we take this instead of creating a entirely new table? Can we write a subquery that can replace this? Yeah, can we do that? Look at this query. This is also giving us the result. So this is the query. This is the final result that we got from the previous query. This query right here is also giving us the result. What is happening here? If you think about it, in the previous query, in this query, the department salary was created from the employees table only. There's no separate table. This is also query A is also employees table. This is also coming from employees table. It can come from, there's no constraint that the subquery has to be coming from the same table. That's not like that. Just understand both of this is coming from the same table. Now here, look at this. Look at this. In this one, we are completely replacing a join. We're completely replacing a join with this command. We are not joining anymore. All right. So we are taking the name. Name is present in employees. Salary is also present in employees. Only retain those records where the name and the salary, those records, that is the name and the salary, retain the name and the salary. Only for those records that is satisfying this condition. Getting me? Only retain those records that is satisfying this condition. This condition should ensure that the salary is greater than the average department salary. Okay, so let's understand this a bit more clearly. What happens in this? It's very, very important for you to understand what is happening. So here, say we have the employee name, we have the employee salary, we have the employee department. All right, these are the only three data we need for writing this. We have department means department ID. This is department ID. So name, salary, and department ID. Is there any other column involved? No, right? Only three columns involved here. All right. Now we have the first record, second record, third record, fourth record, fifth record. Let's say there are 5 records. We have 5 records. Now here it will just select in this query. What have we asked it? Select the name and the salary. Name, select the name and the salary. And when it reaches the where condition, it will go row after row. For every row, this where condition, it will check if this where condition is met or not. Okay. For every row, this where it will check if this is getting met or not. Now here, it comes here, the very first row. The very first row. What is the condition? Salary, this column, the salary column. This salary column is greater than the salary. This particular value. When the iteration is in this row, let's say the iteration is in this row. All right. Here, this salary is here. Whether this salary is greater than this, the output of this query. That's all. The salary is greater than the output of this query. Let me write it in a yellow color. All right. So output of this query. This is the query. Now what is happening here? What are we computing from this query? Select the average salary. Right? Select the average salary. It says E2. This employee is here. We are referring to employees again. We are calling this as E2. Average of this employees table. Average of salary of this employees table, where E1.department ID equal to E2.department ID. Right? Now here we are in this record, in this iteration here. Here, let's say the department ID is 1. Or let's call this as department ID is P. Department ID is P, Q, R, let's say. All right, some other values there in the actual data, but let's understand. This is P, Q, and R. This is Q, this is R, this is P, and this is Q. Let's say these are the department IDs. Okay. Now here, what's happening? Select the average of the E2.salary from employees E2, where E1.department ID in this record, E1 table is the entire table. From this query, the main query, right? From this entire table, we are having just one row here. E1.department ID is P. Let me use a slightly different color. E1.department ID is P. Right? Is P. Equals to E2.department ID. In this query, E2 query here, in this query, from this, this ID, this is P, right? Right now in this iteration, this is P, equals to E2.department. It will try to match all the P's that is present in the data. When the iteration is here, first row, the value of department ID is P. During the select operation, it will try to filter all the rows where the department ID is P again here. Because the iteration is trying to see if you can include this row or not. This is in the very first iteration, this happens. So you take these two rows, and compute the average salary for P, department ID equal to P. All right, so you will take these two values of salary, average of salary, compute the average of these two values, right? And see if, so salary we have one value, salary over here. The salary is greater than or equal to, I want to erase this, but if I erase this, everything will go off. Okay, so here, if this salary is greater than the average of department P salary or not, if it is greater, then this row will be included. Otherwise, it will not be included. All right. So let's say this is greater than this, then it got included. Next, the iteration will move to the second row. Right there, it will look at what is the department ID here. It will take the salary. It knows this salary is greater than all the Q departments, department ID equal to Q. It will compute the average of all the Qs, right? All the Qs, it will compute the average. Then compare if this salary is greater than the average of the Q salaries. If it is greater, then this will be retained. Otherwise, it will not be retained. It's a very, very minute breakdown of what happens during this query. Is this clear, folks, what I just explained? What really happens during this? Yes, clear. This should give you a little bit more detailed understanding of how the where condition works also in the first place. All right, where that particular row salary, this where condition gets applied on every other row that exists in the data. Right, it will go over first row, second row, third row, fourth row. In every row, this condition gets checked. Right? In every iteration, it will compute this. It will compute internally, it will be optimized. Okay, but for our logical understanding, internally, every other row, it will compute the output of this query and do the comparison with the salary data. Salary that is corresponding to the respective row. If the salary is greater than the output of this query or not. If it is greater, then this will be retained. Otherwise, it will not be retained. That is the whole funda that is happening over here. So effectively, we have written a more complex subquery to check if whether a given department's or employee salary needs to be retained or not. Okay, we have written out how to understand this query also. Let's do a little bit more tougher example. Find out the employees who sold product A and sold more than the average quantity sold by all the employees. All right, so we are venturing outside of the employees table. The employees table does not contain the product information. All right, so what we want, we have the employees data. We want the names of those employees who sold product A and sold more than the average quantity sold by all the employees of product A. If we're talking about product A, how to solve this? Now we know that to do this query requires information from both the product as well as the employees table. All right, so first step, you need to figure out what tables you need. Right, so we have three tables. We have the sales data, departments data, and the employees data. Employees data contains the name and the salary. This is what we want. We are interested in. Right, a name, that's employee ID, name, and salary. And sales data contains the product information. Okay, from this we want employees who sold product A. From this table, we want employees who sold product A and sold more than the average. Getting me? Now pause and think a little bit. If you are watching this in a recorded mode, you can go here, dbfiddle.com. You can click on this link and you can try and solve this as well. All right. This one contains the employees data, employees table, departments, and the sales data also. All the three tables is getting created over here. And you can take for the next 120 seconds or 180 seconds, give it a shot at solving this problem. If you are watching in a recorded mode, you don't need to do it right now. For people who are watching it live, you have separate set of exercises for that. If you are watching it in a recorded mode, pause the video and try solving this for the next 180 seconds. All right, let's move on. First, find the total quantity sold by each employee for product A. First step. That's already information is already present, right? So we know we have the employees data from employees table. This contains the employee ID, right? Products table, that is the sales table, contains the employee ID and product information, what product and the quantity of the product. All this is present in the sales table, right? Employee ID, name, and everything is present in the employees table. We need to join both of them to get that information. So this is the employees table. Just first two rows I'm printing out, and this is the sales table. We will join them based on the employee ID. S.employee ID, E.employee ID, and S.employee ID. We will join them based on both of this. That should give us the name, product, and the total quantity. I'll show you this query once more. So here we are joining employees with sales. Employees contains the name and the product. Sales contains the employee ID, what product it is, right? And we are filtering out only those records which contains product A. We are concerned about only this record, product A alone. Okay, so we have this information. So these are the 4 employees who are selling product A and the total quantity sold by these employees. Now, once this information is computed, we just need to take an average of this column. Right, say this is average is say 7.5 something or 6.5, I don't know, right? Then select those records that are greater than the average. This is lesser than, and we will drop this. So that should be the result. Yeah. Now, in order to do this, so here we need to compute the average of total quantity. A new column needs to be added over here. That is the challenge with writing this query. This is the specific challenge with writing this particular subquery. How to do this? So here, the same query we are using. Same query, name, product, and total quantity. We're calling it as the total quantity of that employee, right? We want to retain those records where the total quantity here. What is total quantity? Here we have the total quantity of product A sold by all the 4 records, 4 employees, right? So total quantity is present already. We want to retain those records where total quantity is greater than the average of total quantity of product A sold by an employee, the 4th column that we wanted to create. But we know that we cannot compute an average of quantity here in this one. So we need to write a select statement. Select star and whatever we want to compute from whichever table, right? This part we need to replace. Select sum of quantity, right? So select sum of quantity where product equal to A, group by employee ID. So these are the amount of quantity sold by each of the employees. We have this, but we want the average of this. So select sum of quantity as product A. So from this we are computing the average here. From this query, we are computing this average and storing it as average underscore A. This one, we need to merge it with the original table. We need to merge it. So this part, we are merging it with the original table. And this is the average quantity for product A. That's it. That's the answer. Only those records where the total quantity is greater than the average product A amount for average sales or average product A sold for average sold for product A. Only those rows will be retained, and that's the answer. That's all. So Alice and David are the only two candidates, employees who meet that criterion. This query should make sense, folks. Okay, if you are able to read how this particular query works, then we have achieved the purpose of this particular lesson. If this query is clear, especially this part of the query, is clear, please write clear on chat, and I will know that everything is clear. Great, thanks for confirming that. Anyone having any type of doubt with this? Okay, Salman, thanks for asking for that. Let me quickly recap this. So what has happened in this one? So let me quickly recap what we did with this particular case. Right, find out the employees. So from the employees table, we have the employees ID. This information is present. Right, we also have the quantity sold and what the product is. Right, we want those employees where who sold product A, who have sold product A, where the average amount of product A sold, the total amount of product A sold by a given employee is greater than the average of product A sold by the employee sold product A. And that's what we want to compute, isn't it? In order to do that, we need information from two different tables. The employees data does not contain information about what product they sold. That is present inside the sales table only. Getting me? That is present inside the sales table because it contains the employee ID, product, and quantity. So we need to add this table to this one. Bring this information for every employee. What is it? Product quantity. So total quantity sold and what product it is. Right? That's what this query does. So we are taking the name, product sold, and total quantity sold, where product equal to A. That's what this query does. And grouping by the name of the employee and the product. All right. And we are retaining only product A here. So this is the output. So employee, product name, what's the total quantity sold. Now we want to know the average of total quantity. Right? Average of total quantity. If this is greater than average, right, then we will retain those records. Otherwise, we will not retain it. Getting me? So in order to get the average of total quantity, we are putting that information. We are adding this criterion here to that query, where total quantity is greater than the average of the total product A sold by an employee. This cannot be written like this. We know this, right? Average of total quantity. We cannot do this. Right? To do this, we need to write a subquery, select statement. That is the statement we are writing at the bottom. This one, finally this one. So select average of the sum of quantity when product equal to A. Okay, this part we will replace it inside the statement we had written earlier, right? Average total quantity sold we had written earlier, right? In that area, we have replaced this part. That's all.